Uh, Good morning, everyone. Thank you for joining my session today. My name is Mohammed Wali. I work as a solutions architect for AWS Solutions Architecture team, mainly acting as a technical advisor for large enterprises and retail customers within Belgium, Netherlands, and Luxembourg, based out of Amsterdam, the Netherlands. So it was a heck of a kind of long flight for me, still quite jet lagged, but very excited to be in Chicago today. So today I'm going to talk about the AWS security reference architecture. But before getting started, I have a confession to make. This is not like a level 400, level 300 session. We only have a 30 minutes time slot via which we're going to introduce the solution, how to use it, what kind of benefits it brings. So if that's not what you were looking for, if you think another breakout session can be more efficient for the sake of your time, please feel free to join it. So with that said, I'm quite curious to know if any of you is already familiar with AWS security services and has used at least one or more AWS security service before. Please continue raising your hand if you have used 3 or more security services. All right, that's still 50%. 5 or more? 10 or more? All right, so pretty much at least the majority are quite familiar with the different, or at least 3 or more security services on AWS. So for those who are not familiar with the full stack, actually, throughout the session, whenever I refer to any of the security services, I would quickly introduce what it is so you get some sort of a grasp about what is it. So what we're going to talk about today, first off, I'll introduce the AWS security reference architecture, which I will abbreviate as AWS SRA most of the time, what it is, why you should use it, and why you actually build it at the first place. And for the sake of the session time, we'll not really be able to go through every single trench of the solution. Therefore, I was focused more on the highlights of the solution. And last but not least, we'd have some time to walk through the code repository and the documents used to implement this architecture eventually. So AWS SRA, what is it? It's simply a holistic set of guidelines for deploying the full complement of AWS security services in a multi-account environment. And this can be quite useful really when it comes to designing, implementing, and even managing your different AWS security services on AWS while making sure that they are aligning with the recommended best practices. So these recommendations are built around the single page architecture that you can see on the left side here, which pretty much includes different accounts and different OUs with many security services running within them, mainly elaborating like where exactly should be deploying these different security services and how they would be interacting together, and more importantly, how it can help you to achieve your security objectives. So the accompanying architecture and the recommendations are mainly based on our real-world experience with certain enterprise customers that we started off the solution with until we open sourced it at some point. And it's written down in a document which is actually published in AWS Perspective Guidance, which I'm going to share its URL with you later on. So this solution or this document is meant to be used as a reference for you to deploy this comprehensive set of AWS security services if you would like to secure a multi-account environment. On top of that, we have the AWS SRA code repository, which you can see on the down right side, which pretty much includes some infrastructure as code modules that can really help you to get started to deploy this distribution, so you don't really have to reinvent the wheel. Why did we build it at all? What was the motive? So pretty much throughout our discussions with the customers, we got to hear that they were quite happy with the fact that we are always publishing some best practices, making sure our documentation is always up to date, covering many secure services in different blog posts, or maybe even how to integrate 1 or 2 of these services. But what they really missed was, all right, I have a lot of security services. I need to fill the gap of making sure that how can I have pretty much a helicopter overview about the full security stack and how they can work together. And more importantly, where to deploy them in order to make efficient use, because by the end of the day, in a multi-account environment, you have many, and you still, for an architecture reasons, you would like to make sure that they are deployed in the most efficient manner. And eventually that should help you to achieve your security objectives. So these were kind of, some sort of the conversations we had at the beginning with the customers, why we actually come up with this solution eventually. So with that, how can it really help you? How you can get benefited from the solution? So the AWS SRA can help you, depends on actually where you are in your cloud adoption journey. So can really help you to define the target state for your own security architecture. If you're fairly getting started with a few set of accounts, or even if you already have a well-established AWS environment, you can actually use a AWS SRA to help you define this kind of security architecture environment, customize it to meet your requirements while also utilizing the solution, so on and so forth. But what if even you already have your own security architecture? In this case, you can actually use the AWS SRA as some sort of a reference that you can review your existing security architecture against it. And by assessing what you have against it, you can be more confident that if things are quite similar, then you're more confident about that the choices you have chosen are actually aligned with what we normally recommend. And if it diverges from the AWS SRA, which can happen, well, at least it can raise some sort of a flag that maybe you need to review the design decision process that came up with the way you are doing things. By the end of the day, there could be actually some legitimate reasons for why you might diverge from the AWS SRA, maybe, for example, to meet some certain industry requirement or so. Once you decide to proceed with the solution, I can imagine that the most tough thing is really to go ahead and implement it. And that's why we have open sourced the solution, or some of the solution examples that you can use to bootstrap your environment, so you really don't have to reinvent the wheel. So in the AWS SRA code repository, you can see the different infrastructure as code modules that you can really use to deploy different security services, either on the account level or pretty much on the whole organization level. Throughout your journey with AWS SRA, you would actually get to learn more about the different security services and capabilities. Because in the documentation that I will refer to you by the end of the session, it actually covers different considerations and caveats you need to watch out for when you are integrating pretty much all of these services. So that would kind of upskill your knowledge about AWS security, especially if you're not 100% security specialist, while also is having this kind of high-level introduction through the depths of the different AWS security services. You would be more familiar about what kind of functionalities every service is offering. And last but not least, it can help you to drive a discussion about the organizational responsibility, when it really comes to security. And that's a key element really when it comes to coming up with a security architecture or security strategy, is really to understand who is responsible for what. So defining ownership is quite a key here. And for example, maybe one of the questions that would come up throughout this conversation is, where should I be really aggregating the security findings? And that also brings us a question of which team would be responsible for this activity. Another one could be, are all the findings would be managed by a centralized security team, or would every application team own their own security monitoring as well, which means they would also need further permissions over different AWS security services. So these are the kind of discussions you might be having, which can kind of help you to have a more clear overview about your security responsibilities within the organization. So with that, we got to know what is AWS SRA, a bit of history, like why did we build it in the first place, what kind of benefits it can bring to you. Now let's have a look at the architecture of the solution itself. So when we built the solution, we counted on these three frameworks as part of security foundation that we can build on. So we use the AWS Cloud Adoption Framework, we use the AWS Architect Framework, as well as the shared responsibility model. So the AWS Cloud Adoption Framework, in case you're not familiar with it, it's mainly a framework made by AWS to help you leverage AWS experiences as well as best practices to accelerate your business digitalization on AWS Cloud and recognize the business value out of it. And it consists of 6 perspectives. One of these perspectives is about security. So it kind of guides you like how to implement the right security controls in order to eventually meet your regulatory requirements. And that's what we counted on, or what we took from the Cloud Adoption Framework. The same in the AWS Well-Architected Framework, which is simply a framework meant to help you to come up with pros and cons for choosing a certain decision when it really comes to architecting a workload in AWS. And it consists of 6 pillars as well. One of these pillars is about security, which kind of guides you how to assess and protect your data while you are designing your workload on AWS. And last but not least, the shared responsibility model, which is, we tend to say most of the time that security is a top priority at AWS, but still kind of a joint journey between ourselves and our customers. So when we talk about some services such as EC2 instances, for these, we do take the full responsibility when it comes to security from the facilities in which our services operate, all the way up to the operating system of the host in which your EC2 instance runs. Of course, this ownership can go more beyond that, depending on to what extent the managed service you are using has more stuff for AWS to own. But by the end of the day, as I mentioned, it's a joint journey. For example, if you create an S3 bucket, we do expect that, at least on your side as well, you would be blocking the public access, you would be encrypting your S3 bucket, so on and so forth. So as mentioned, this is actually what we counted on when it really comes to the security foundations of the solution. This is some sort of high-level account structure. As you see on the left side, we have an AWS organization within which we have different organizational units. And on these different OUs or organizational units, we have different accounts meant to achieve different purposes. So for an account structure perspective, we also counted on the concept of AWS organization, as well as a multi-account strategy, which you can find them in more details in the AWS documentation, covering the different types of organizational units you can create, the different accounts you can create, and what kind of purposes are behind this, so you can choose the type of your account, position it on the right OU in the most efficient way. And this was another thing that we really counted on while we were building the solution. So with that, I think you get a grasp of actually what AWS SRA. I've been talking a lot so far about, how cool it is. Now we can actually dive a little bit deeper into the solution. As you see in this architecture, it's a little hard to read. Actually, we have a lot of accounts with too many services running in them. So let's actually take it an account by account to see what these accounts are doing and what are these security services are doing and interacting, how they are interacting with each other. So in this diagram is the security tooling account, which is part of the security OU. As part of the initial architecture that you saw in the previous slide, we do recommend that you have a security tooling account within a security OU. So you need to have that dedicated one. And it's kind of dedicated, for security, for operating security services, monitoring your security findings across your organization. That's what this account is meant for. That's why we have pretty much all of these different security services that can really help you to, achieve or help you to address different security requirements. So if we started with a service such as AWS Security Hub, this is kind of a service responsible to run automated checks for your AWS resources within your organization against certain regulatory frameworks, which could be CIS, for example. So this service not only assists your resources against these kind of frameworks, but also help you to build or pull the security findings from other different security services running within this account. So if we're talking about a service such as Amazon Guard Duty, which is meant to detect any malicious activities in your account or any suspicious behaviors, that can be eventually reported as a finding, and eventually Security Hub can pull this finding to centralize it in its own dashboard. The same applies for Amazon Macy, which is meant to be a data classification service and can help you to detect any sensitive information that you might have running in your S3 buckets. And I can imagine that there are some very strict compliance requirements when it comes to HIPAA or GDPR in Europe, for example, where you really shouldn't be storing any sensitive information in your S3 buckets, for example. That's where this service can help you with, and eventually the AWS Security Hub can pull these security findings and store it with the AWS Security Hub. The same applies for the other services that integrate with it. For example, AWS Config can help you to detect if there is any configuration changes for your resources that might put them in a non-compliant state other than the desired state you would like to see them in. So eventually, pretty much these services can report its security finding to Security Hub. And to take these findings further for troubleshooting, you can use Amazon Detective, which can help you to visualize your security finding, dive deep into it, get to know what is the root cause of this problem. And from there, you can actually start to address this problem. Eventually, the AWS Audit Manager can actually use pretty much all of these security findings to create some sort of an assessment reports that you can use for frequent auditing for your whole security landscape. So you get to know where you are in your journey to enhance your security posture in general. So this is the very first account that we do have. This is the kind of service you'd be having, and they run on the organization level. So they don't only get what you have in this account only, but pretty much they would be considered as a place to centralize the management of these security services, as well as the security findings storing in this account. Another account we have in the security OU is a log archive account, which is dedicated to ingesting and archiving all the security related logs and backups. So with centralized logs in place, actually you'll be able to set up something like, proper monitoring and auditing for your sensitive logs. So for example, if there is any unauthorized access to the S3 bucket in which you have your logs, or any IAM policy changes that maybe give some sort of privileged access to somebody, you can be notified and you'd be able to monitor your security logs all in one place. These security logs can be coming from different security services. So if we're talking about VPC flow logs or DNS logs, or even CloudTrail logs, which capture the API activities across your organization, that would be actually the place where you are storing and putting your logs in. As you see in the bottom, there are some services that we actually covered in the previous slide, but let's keep them there right now. I will tell you later on why you actually see them in pretty much all of the accounts that I would be walking you through today. Another account that we do recommend to have is the shared services account, which would be part of the infrastructure OU. And it's actually meant to operate your commonly used services that can be used and consumed by other accounts running in your environment. Think about something like Active Directory, for which you can use AWS Managed AD, which can be used by different Microsoft workloads running across different accounts. The same applies for messaging solutions and so on. So for a security perspective, it's highly recommended that you have this kind of account to store your different security services that can be consumed by others in. And that takes us to the last account that I'm going to talk about as part of the architecture, which is, the application account. That's where you're actually running your applications. So pretty much I can imagine that you have many of those running in your workloads OU. And as you see in this diagram in particular, we don't only have security services, but also we do have other services which are not necessarily security related. So because that's where we are running our applications. So what I'm going to do for the sake of showing an example in this case, I have just, have a 3-tier web application exposed via the application load balancer. The application runs in the EC2 instances and stores its data in the Amazon Aurora database. So you still can see other security related services, but that's more on the account level, such as Secrets Manager, which can act as a secrets management service, helps you to store your secrets, rotate your secrets. So if your application running on your EC2 instance would like to access the database, so storing the database connection string can actually happen in the AWS Secrets Manager, or if it tries to reach out another API for which it needs a token, that's where you can actually store it. And using the right IAM policies to restrict the access for it, the application would be able to retrieve the secrets from the AWS Secrets Manager, and eventually you will not have to hard code any secrets in your application code, which is against any best practice in general. Also, another service such as KMS can really help you to protect your data at rest. So thinking about protecting the APS volumes by encrypting them with KMS, and the same for the Amazon Aurora databases. So with that, let's really see how that can look like in a real world example. What you see is 3 orange boxes here, and I'm going to walk from left to right, starting off with the AWS Systems Manager agent, which is quite an important service for security, mainly because via the AWS Systems Manager agent, you would be able to update your own EC2 instances on which your application is running. It can be used to establish SSH connections to your EC2 instances without having to expose the SSH port, because in this case, you can use Session Manager instead. It can actually also, or actually Amazon Inspector, which is a vulnerability assessment service that can help you to detect if there is any vulnerabilities or any unintended network exposure in your EC2 instances, actually depends on the AWS Systems Manager agent itself. Moving to the second box, we can see that we have different endpoints for different AWS managed services, such as KMS, Systems Manager, so on and so forth. So these endpoints are applied on the VPC level, granting the resources running within this VPC direct access to these services via the backbone network of AWS. So you really don't have to go through the public internet if you need to communicate with these services. You don't have to establish any VPN connections, use transit gateway. By the end of the day, no complexity need to be introduced with such a basic type of communication. And that's why we do recommend also on the PPC level to use the VPC endpoints. We can even go farther with it, where we can set some security groups to restrict access to these endpoints. to make sure that it should accept traffic only from the right resources. This case could be only the EC2 instances. And we can even set some sort of endpoint policies that would restrict the access to the different principals running within your account. So maybe you would say that only an EC2 instance with an IAM profile with these permissions would be able to access it and have this kind of permissions that can execute against the service it tries to communicate with eventually. All the way to the right, where we can see the last box, we are having different security services that we have quickly covered in the very first account, the security tooling account. So what you see over here is the very same services, and that's mainly because what we saw earlier was more on the organization-wide, but what you see here is more on the account level. These services are quite agnostic. They are not meant to be only deployed on the organization, but instead they can run on the account as well. So eventually the application team that has access to this account can check their security findings from these services, as well as the centralized service itself depends on these services to centralize all of the security findings coming from it as well. So with that, I really would like to take a quick pause to review what we just covered in the previous section. So what we did quickly was we just talked about the high-level account structure, what kind of accounts and what kind of OUs we have, and where exactly we should be placing the different AWS security services. So the last section here is I'm going to talk about how we can actually eventually apply these security services at different layers for a normal AWS environment. And that's how we see how an AWS environment looks like. You have an AWS organization. Within it, you have different organizational units. And within these OUs, you have another layer for the AWS account itself, which is considered by default some sort of a logical security boundary. That's why we do recommend to make sure that you have an AWS account purposed only for one reason, which is to run a certain workload, so you don't extend the footprint of the account itself. Network and content delivery is not necessarily a layer, but it's more a level that can support the workloads that you run on your AWS accounts, all the way to principals, which are represented by the identity pieces, down to the resources, which you need also to secure the access to these resources, making sure they are encrypted as well. So to quickly see how we are mapping these services, as you see on the AWS organization and the OU level, we have these kind of organization-wide services, thinking about something like AWS CloudTrail that you would like to apply across your whole organization. That's actually where you can, or that's the layer actually where you are positioning it. The same for the SCPs, which is the security control policies, can apply it on AWS organization, as well as the different organizational units to achieve different purposes or to restrict down the access. And when we move one more layer to the AWS account, we can see that we have also still some of the similar services we saw on the OU, but these ones, as I mentioned earlier, are more of account agnostic. They don't necessarily have to run on a single account over the other, or be deployed only on the organization level. In fact, they can be deployed on the organization level as well as the account level, together with some other services that you can utilize, such as Secrets Manager, KMS, which I talked about earlier. And then moving to the network and content delivery, that's where you can actually see the different network security services, such as AWS Firewall Manager, which can help you to set up some sort of a baseline for your security groups, for your web rules, so on and so forth. AWS Shield, which can help you to protect your workloads against DDoS attacks, together with other security services, such as the VPC endpoints that I covered earlier on. Moving to the principles, that's where you control your identity. So you're making sure that you're applying the least privilege approach, you're restricting down the access, you're setting up sessions, you're setting up some permission boundaries, so no one in a certain account can go over what you initially set for them, so you prevent privilege escalations, all the way down to the resource itself, which you still need to restrict the access by using some policies with these resources. As well as utilizing other services such as config to detect if any of these resources is not compliant with the desired state or not. So that's how actually we try to position the different things on different layers. So by the end of the day, you are having multiple layers of protection to make it quite hard for any intruder to reach your resources, which that's where actually your services and applications are running. Last but not least, I would quickly walk you through the AWS SRA code repository so you know what's already in there and how you can use it. These are some of the examples available in there. So you can actually implement pretty much all of these solutions organization-wide. Some of these solutions are account-wide as well, such as setting up IAM password policy on an account level, making sure S3 buckets are enabling the blocking the public access, so on and so forth. And this is how the repo looks like. It's meant to be self-service. Since we open sourced it, it's already very well explained. You can just go ahead, read what you already have in there, follow the deployment instructions, and you should be good to go. As I mentioned earlier, it's built from our own experience. So this is actually what we use to deploy for other customers. So it's meant to be high quality with a decent testing in place. And this is actually an example of what's included in the repo. So for every solution, that's what you would be seeing. Some sort of an architecture diagram telling you exactly how we are trying to implement this solution, giving you some resource description for every single resource used as part of this architecture and why it's there. And pretty much together with the deployment instruction that you need to follow in order to eventually implement the solution. And of course, it follows the least privilege. So when it comes to IAM rules and policies being used as part of the solutions, we are following the least privilege approach. Once you deploy them, you still can follow the post-deployment steps to verify that your deployment has gone successfully. So with that, I think we have run out of time, but please scan these QR codes to be navigated to the document of the solution, as well as a code repository for further information. I would be here wrangling around for the rest of the day. So in case you have any questions, please feel free to reach me out. So with that, I really would like to thank you for joining the session today. I hope you found it informative, and thank you so much.
It is still morning. Good morning, everyone. Hi, my name is Danielle Wilson. I'm actually based out of Denver, Colorado, originally from Kansas City, so still consider my part of the Midwest user group, but Senior Director of Channels West at Mixed Mode. Here today to talk to you about multi-cloud environments, cloud transformation, going to these environments, the risks versus what we've standardly dealt with on-prem environments versus these multi-cloud environments, and just some recommendations and thoughts of how we move forward with the fun times ahead. Personally, love making my presentations interactive. So if there's ever any questions, comments you want to throw in, throw at me, throw at each other, feel free to during the presentation. But you'll see it also kind of dictates towards some open discussion toward the end. So no question's a bad one. Feel free to throw at me whatever you want. So kind of kicking off, as I mentioned, the conversation's really going around cloud transformation, how we protect our environments out there. Some of the major concerns executives such as CISOs are seeing just based on conversations and how we're going about these today and why these questions are being asked. I feel like most people in this room, most practitioners understand there's a world of difference between on-prem where we had one exit, one entry and threats, more or less. I mean, more or less, right? But with these cloud environments now, AWS, any of these multi-clouds right now, there's multiple points of exit entry. There's multiple points of threat vectors there. It's very nebulous. It's no one knows what the enter out is. And some of these top questions that we're starting to see just as vendors out there is what data exists across my environment, across my cloud environments right there. There's just a lot of shadow data assets out there, a lot of legacy storage, idle assets that haven't been used lately. We all know that a typical CISO anymore, their average tenure is 18 months. And it's kind of a CYA policy while they're there, right? Sometimes you don't want to know what was hidden before you came in place. You're not necessarily considering what's coming in after, but it's that tenure that you're there for. So those shadow data assets of really not knowing what's there. I've had many conversations with a lot of CISOs out there. You would be amazed from the business perspective side of how many people think they operate in one cloud. I only have AWS in my environment. Start looking at it. Most enterprises and SMBs have at least 2+ clouds out there, whether it's a AWS and a small GCP, a Databricks, there's a lot out there for that. Another conversation that's coming up is who's using our most critical data out there too. Data misuse, it's a huge one. Phishing attempts, DDoS attacks, email spam out there, compliance breaches. Another thing we find, there's so much data that's just OTW, open to the world out there, that they're thinking was not, and I mean, creates huge compliance risks, whether it's HIPAA, GBLA, any of these compliance SOCs out there, when companies aren't realizing where their data is at, because again, they have no idea how to look for it out there. And then how can we stop sensitive data from being exfiltrated? Data exfiltration happens all the time. You got a rogue employee, an ex-employee out there, ransomware attacks. How do we predict when this is going to happen? How do we know this is going to happen? And how do we remediate this in a tight time frame there too? And the concern with the cloud data is because this is what the hackers and the threats are coming after. Because why? The cloud data stores, that's what has the monetary value for these companies. Why would you go for something else? So everyone's trying to attack this data, and there's just so much of the data out there. We've got different types of data. We're seeing that 40% of cloud resources right now are data assets. That's a lot of stores and a lot of information for hackers to come out of. And our problem is when we're looking at the PaaS assets, the managed assets, the S3 buckets, the IaaS assets, the virtual machines, your MongoDBs, your VMware instances coming up, and even the DBAS out there, the Snowflake and the Databricks, because I don't want to pay for all this money on my other cloud. So I'm just going to segregate it out to everywhere. How can a human really handle all that? 20 plus types of data assets per enterprise. CISOs don't know where their information's at. This is where kind of the AI is kind of coming in there, because AI, again, and we'll get into this in a little bit later too, it can be predictive, it's self-learning right there, and it eliminates the human mistake. When we're dealing with this much, you could be the most intelligent human out there. You can't handle all this type of data out there, and it's becoming remedial. There's different activities that the humans can be doing in these environments to really make a difference, rather than just trying to self-train, accidentally mistake, accidentally misconfigure, accidentally miscategorize something out there. So really with this is avoiding bias is the key to a successful cloud transformation, in my opinion, and some other people's opinions too. I know AI is kind of a tricky word right now, and it's very overused. It's becoming another acronym almost, but let's talk about it for a second, because when we're having human interaction and with all the XDRs, NDRs, DDR, every DR out there, we're still coming out with that human interaction right there. For example, you look at those top three, the rules, the training data, out-of-date IOCs on there. The rules, they go in, but sometimes never come out. So what's that do for you as a good rule? Are they even correct? Who put those rules in place? Do you have turnover on your teams right now to where you're not even knowing why that rule was created, where that rule resides, if the information for that rule is still imperative for your organization? And then we look at stale privileges and vendors. That's another big one right there. Again, especially with turnover, so many third parties come into organizations right now. Have privileges been turned off? Have they been turned on? Are they correct? Are they able to access the appropriate information? Are they accessing information that they shouldn't be accessing there too? And then misconfigurations. I mean, that one kind of speaks for itself right there and kind of falls into others. I'm yet to find an environment that has always been perfectly configured. I'm sure everybody else feels about the same way here. So with that, again, talking about all the acronyms here, the biggest problem, we can call it what we want. We can call them SIMs, XDRs, NDRs, everything out there. But really the biggest problem is we're hearing a lot of noise. Companies are dealing with a volume of data. We're trying to focus on tool consolidation and control costs. We're wasting time with the human interactions where humans can be doing great jobs. It's just with this data, it's too much. 426 hours a week and false positives. And then we're still getting with 80% of CISOs still can't figure out where some of their data is at. I'd rather be doing something else. So it really brings it to AI. And some of you guys in the room may be may be old enough, such as myself, to remember Mad Magazine, and they always said spy versus spy in those. Well, now it's kind of like the AI versus AI is a great way of looking at things. Bad actors are using AI. You got to be able to combat it at the same level. The bad guys have weaponized AI. Now, what I've done previously is I've even had some jokes with some of my colleagues about this too, and say, you can't really just speak about AI without context in there. I'm sure some of you guys too were at RSA over the last couple of weeks. Everyone's talking about AI, but AI without context doesn't really make a lot of sense. It's just another XDR, NDR, DDR type of terminology right there. But with AI, what you do, you can see the speed, scale, and savings that you'll see in your environments. Now, talking about AI, I'm sure some of you guys are aware too, AI waves, there's 1, 2, and 3, all is recognized and defined by DARPA. Wave 1 AI is going to be the simplest. It's expert systems, not to dumb it down, but think of something like TurboTax, but you got to start somewhere with it. You put your information in, it can do simple calculations for you, it spits out a result. Wave 2, statistical learning, a little bit smarter right there. Uses training networks, neural networks to label things. For example, if a neural network looks at dogs and cats, it can say that's a dog, that's a cat. If it sees a zebra, it's still going to define it as a dog or a cat. It doesn't have that extra level of intelligence. It has intelligence that was fit onto it from training data. So it has to have the knowledge already there to be able to explain. Now, wave 3 is where it gets really interesting. This contextual reasoning, looking at real world phenomena right there, takes into consider the context of the situation. For example, the time of the week, the time of day, the day of the week, who the conversation's with, how long this conversation happened to, who the conversation was about. So there's 4 attributes that really make third wave AI different than the others. It's self-learning, predictive model, it's contextual, and it can be abstract on there too. Today, for third wave AI from a commercial perspective, mixed mode is the only one by DARPA that's able to deliver this to customers. Now, kind of going back to it all, because the reason I wanted to bring AI into this whole cloud transformation one, because of the scale, because of the speed, and the cost savings, and to allow people to do what they were trained to do and do something interesting instead of just diving through a bunch of data right there. Whether you're on the AI bandwagon or not, that's a conversation, but this is what I ask you to look at when you're looking at cloud transformations moving forward too. Does it rely on clustering, labeling, or people? Because you're adding bias into your project right there. How do you know your cloud infrastructure is what you expect it to if you are not the one that put all that information in there and you can't be positive on it? Is it based on historical data? And is that historical data right? Are you smarter than the bad actors that can change the data around? You might have had insider threats. Have you been able to confirm that these are not affecting us? Who trains, tunes, and maintains your cloud infrastructure? Do you keep appropriate records? Are you guys even sure that how it's set up right now is your most secure environment? Is the cloud data dependent on rules? What if those rules are off? What kind of misconfigurations or gaps is that providing into your security infrastructure? And number 5, how are those novel attacks handled? Again, with AI, what it's doing, it's self-learning those environments, cloud or on-prem, but we're not going to talk about on-prem today. It can start predicting when this is going to happen. This is something that unfortunately we're just not capable always of doing as humans on a constant basis. How are novel attacks handled? So with that, I know I kind of spoke a little fast. I wanted to be cognizant of time and kind of keep us back up, but we've got 10 minutes. I do want to open it up to questions, thoughts. What's everybody think about AI, third wave AI, or are your organizations, are you guys dealing a lot with cloud transformation now? Do you see these issues? Because one of the things I like to do when I'm having these talks is get feedback from everybody in the room too. Understand what you guys are seeing. Am I way off? Do I not know what I'm talking about? Comments?
Cost. That's my comment. Cost of, yes, AI, but the cost of AI. You're looking at this.
Cost can be prohibitive at times, but then you're kind of comparing your cost of a breach versus the cost of maintaining the AI infrastructure on here. I will also make comments that I know that, for example, AWS is doing a very good job with their AI vendors and customers out there trying to curb some of these costs down, especially from having to run instances and environments, just kind of those cloud costs, if you will. But I do understand where AI technology can be expensive, but when looking at the cost of the humans right there, as well as the potential breach, it can be very counterintuitive on there as well. Yeah.
I mean, AI can be used for a lot of the tasks that we're doing right now. A lot of the people are doing tasks, and we can change that with AI. But it does require a lot of work and a lot of knowledge too. OpenAI has their API where you can write code that basically does certain tasks. I experimented with this a little bit. One of the observations is that it's still a little bit early, but we cannot know exactly how far we can take this.
Right.
So an example of that, it is in handling, for example. You can actually have an AI assisted system that will go through your logs and then derive conclusions from that. The problem with it is the limitations with OpenAI, that's one. And the second thing is that data privacy. If you're in AWS and then you're sending data to OpenAI, that might be an issue. But now we have Bedrock from AWS.
Right.
I don't know if you have seen something.
So that's going to be when we went to the slide of kind of looking at this too, and the different versions of AI there, 1, 2, and 3. What you're describing right there is very much on the wave 2 AI, which is 99% of what you're seeing out there right now. It's when you're hearing AI, and all these, it's mainly always going to be wave 2, and that's because it doesn't have that self-learning and that predictive nature yet. So yeah, like the chat GPTs out there, the open APIs, those would fall under wave 2, and that's where there's that bit of a learning curve that it still needs to go through. So wave 3, I mean, I think wave 3 is going to be hitting the commercial space pretty hard over the next 12 months. And then, they conceptualize about wave 4 coming out in the 2030s out there, where it's a little more Terminator-ish.
I'm gonna go cry now. Thank you.
No, we don't want you to cry. I think the wave 3.
Have you watched those movies?
I grew up on those movies. Linda was my hero back then. Come on. So, I think that brings up a good point, because I mean, I read the news all the time too. I think there's good or bad, but if we stop looking at it and stop developing what we do on our end, it's going to get a heck of a lot scarier out there. Any other questions from anyone? Well, hopefully this was helpful. Just kind of wanted to provide an intro onto those cloud transformations. Why I think AI is imperative, at least third wave AI is imperative in these transformations to make them more secure. I know I'd rather not have all my personal information floating out there open to the world everywhere. And, and some of the, even though it all probably is already, but yeah, no, I just want to say thank you guys, and happy to jump into any deeper conversations or theories about AI you guys would want to. I'll be around all afternoon. So thank you.
All right, so I think we're gonna get going. I mean, I have way too much content for a 20-minute talk. So thank you for attending my talk. I hope you've enjoyed the other speakers that you've had today. And I know it's right before lunch, so I'll try not to hold you too long. This is not going to be a how to threat model talk or what threat modeling is talk. We just don't have enough time. The whole point of this is kind of shape why and how you can increase the velocity of adoption of services for your business and what that is all about. So kind of as I saw on there, they're laughing. I assume people know what that means. They've experienced that. They've heard it. This is all too common. And when I was a consultant doing this, this is what I heard all the time. I'm at Citibank, very large regulated bank around the world. This happens all the time. So how do I then enable them to get the services and use cases they need out the door? Like time to market is the measurement. So these types of things, we need to figure out how to enable them so they don't do this. The why are we here today? Again, this isn't a threat modeling talk. This is just how do I use threat modeling or use a process to enable the business more quickly. And at the end of this is more of you feel informed about how techniques and methods you can use to enable the business to get to market quicker, and maybe join the communities that exist out there that I'll share and talk about. So again, not threat modeling talk. Threat modeling is just a process. Everybody has a different definition of what it is or where it should be used, but essentially well-defined. It shouldn't be, you think it's this, you think it's this, and the developer in the back says, I'll do it my own way. I don't like those other two. So a lot of smaller, less mature capabilities exist like that, but at scale or when you're trying to unify on how you represent your business or your customers, these things must exist before you go to market. If you're doing it all differently, they're going to be very confused and generally upset, because when I talk to you, I got out the door in 2 minutes. When I talked to you, your report was 110 pages. It took me 6 months. There needs to be some normality. A lot of these things, and I don't need to read the slides, so you guys will have the slides and all that kind of stuff, but the point of this slide is why have a process that's well-defined and integrated into your overall program? Because all of these things you can deliver on. And these are all the things for any mature business process that you're going to encounter. So at finance or other in your business, they already have metrics. They already know, if I build this thing, I get this much money back. That's the efficiency of the process. Threat modeling typically is new to a lot of organizations. I know it's become very popular in the last 5 or 6 years outside of government. That's good. And I join a lot of communities and have these discussions to try and evangelize. But really, I think people are not really getting to the point of bringing it back to the business, time to market. This is the real value that at Citi and other customers I've worked with, we've been able to show this and demonstrate this metric. And so that is from the first day someone makes a formal request to use a service or group of services in cloud, to enablement of you can pull a module and do your deployment as you wish. That's the metric. And so that's what is the context of this conversation. And I'm not even going to put the maturity of the process in there. It's just the value stream, request to delivery. A lot of these slides, I kind of put in the questions I want you thinking in your head to ask yourself. So if everybody has a question while I'm speaking, feel free to stop me, ask that question. A lot of the things that are important about a well-defined process are you start to be able to measure efficacy. You start to be able to do things like, oh, we have a lot of authorization challenges in our applications or infrastructure. So training or technology or other. Those are the types of things that kind of come through maturity. There's going to be process improvements, and we're going to get into that in the next couple of slides, but the well-defined process and the repeatability of it allows you to start focusing on efficiencies, improvements, and just general quality. Again, rate of adoption. Does anybody have a rough number they want to throw out for how long it takes from a business request to deployment? Is anybody brave enough to share where they're at? What I've experienced, I was working at AWS, so global customers, it was 18 months. And each of those customers had a novel approach to how they would review this. And that would be sometimes your enterprise architecture team would sit there and pontificate for 12 to 18 months on theoretical things. There was no framework for the thought. It was just, I'm reading stuff, I'm talking to people, I'm not really comfortable, so we're not going to do this. But they'd hit that magical marker, 18 months, and then say, okay, developers, you can start using this service. But there was no code, there was no prescriptive guidance, there was no alignment to your risk posture, meaning your policies and standards or other security frameworks that you measure to determine, are there actual threats here? So then the developers would start doing things, and we all know sometimes if you are not a security professional, you are all about features and capability and velocity to get it done. And that's where a lot of customers start to fail. So obviously, I'm working at a global regulated bank. We don't allow things to go through without thorough review. So again, this process, having well-defined, well-matured, has helped that. So we're down. Does anyone want to take a guess? Business request for an idea to our lowest level environment to just figure out the idea. Anybody else? Thank you for being brave and speaking. 2 weeks. The reason we can do that is because we've built enough controls, guardrails. We have demonstrated efficacy to all of our follow-on compliance and other functions. So we have second line defense, we have third line defense, IA, ORM, things like that. We've been through our regulator reviews globally. They've all kind of said, hey, this is a good process, and you can demonstrate one, completeness, you actually have controls and a process that's well-defined. 2, you have evidence that the controls actually work. 3, you have code that your users can download and you can demonstrate access control to that, and they're actually using it, and you can confirm it in your operations environment. All those things come from high maturity. You may start at a lower maturity where it's just, I'm reviewing stuff and I wasn't doing it before. That's better than where you were before. You'll mature to, I've written down what I'm doing and everybody that does it is starting to do the same thing. That's, kind of the next steps. That's kind of what I want to talk about here for adoption and things like that. It's not about you have to do where I said where City is today. It's just kind of knowing that that may be a target for you. Somewhere along that maturity curve is where you want to be. Because if you're not regulated, you might not have to have so many processes. But if you care about security, you probably want to start at least asking questions of what type of data am I putting out there? Do I need to protect it? Do my customers care? Like if it's the lunch menu, I don't need to invest a lot of infrastructure reviewing that, but I can post it in my S3 bucket all day long. That's the type of stuff where find your path. So they want to show you this slide and then have people figure it out. But this is something where to production, this is kind of some metrics of what the program has produced. So I knew this would be a pretty short talk, so I just kind of wanted to get to the meat of it of fine, great, you're telling us about a process, but what does it actually do? What have you actually done? And these are just some metrics that I wanted to share. Does anybody measure anything in this way in their environment? Does anybody have a threat modeling program in their environment? Okay. Anybody have a security department? I got a couple. All right, cool. I should reverse that. How many people are developers in the room? All right, more. Okay, so this is not bashing developers at all. The process I've developed actually engages the developers early on. And where I'm trying to get to my maturity model is we spent a lot of time building these controls, defining what the environment is and all that kind of fun stuff. I, at this point, know what the regulator needs us to do. I know what we think is good enough from an infrastructure security and application security perspective. And that when you create a key, it has to be in this region. It has to be these types of controls, so forth and so on. Now, where I'm moving to is I'm going to give my developers a UI where they have an idea. They can just start plugging it in. This service, this service, this service, in this region of the world, public or private, so forth and so on. It builds the Terraform module for them. They say, yeah, that sounds about right. And then they send it through the process. I've demoed this. I can get this done in a week because of the controls we've already built and getting rid of a lot of the process in between now. So threat modeling, the use case ingestion, I'm getting an echo here, things like that. So I really, I felt that that's been a massive change from my experience for doing this for several years. I don't know if you guys feel that's a good thing or bad thing, but as a developer, you raised your hand there on the corner of the front row here. You're a developer. How do you present your use cases and get them ready for production?
I've been both developer and security side. I mean, it's a process from the business comes down to requirements. They get discussed and decomposed between the architects and the developers, down into work, requirements and stories. Those then get presented at, I'll say, sort of group level or product level from product owners with information security analysts, along with the architects who review it at a high level, decide if it needs to be threat modeled and what level of review. And then threat modeling session be scheduled with the development team to verbally go through that as the developers prior to the meeting, diagrammed, whatever it is necessary, or filled out. So template document to bring it and talk through it, addressing questions, and then if there's things that need to be worked, they'll be added as stories.
Yeah. Great. Does people have similar process to that ish? Sure. One of the big things, I just gave a talk at Forward CloudSec a couple days ago. There's a different focus, but still threat modeling. The part of that I was trying to focus on for that audience, and I think it's important here when we're talking about this process, is engineering. Security needs to go directly into engineering. So my threat modeling team writes the threats, writes the controls that they think would mitigate the threats, and they put it in like a Gherkin language. So that's easier to understand. Gherkin is just like a pseudocode language that describes something in more plain English. And that way, when it goes through the Jira ticket workflow, ends up at the engineering teams, and they can more rapidly adopt and build the controls. And they can then write their test cases to show not just, can I lint this out and say 0 or 1, it actually does a performance test and determines, does the intent of the control get enforced? I'll give a real world example. Amazon has services that have to have certain things done at the platform level to ensure performance and other things like that, because they have their own SLAs. We discovered through this type of testing that there was a break in encryption from where we input and where we ended up at the other side. That sort of thing is because we did behavioral testing rather than just, I configured the service to be encrypted. And so those types of things are really useful. That's why we write the control in that way. So the engineers think about that and go, oh yeah, I get you're wanting this configured this way, but the intent is to actually have end-to-end encryption. So how do I actually demonstrate that? And it's the demonstration and the integration with engineering that has really made us more mature more rapidly. And now I can give the developers an opportunity to just say, this is what I want. Here's a Terraform module, run it through all your processes. And I can do that because I know the options they had to choose from, the things that we've selected. So they get freedom to put it where they want for how they want it. And then they have created the Terraform for us so we can more rapidly run it through our process and then give it to them. Simple to complex, we kind of cover some of these things that for the slide purpose, I put it in things at the top of methodologies. There's a ton of methodologies that you can use. On the bottom, these are going to be more things that the details of these things, what kind of context information do I need to think about? This may be what you have today if you've documented something. It's just literally a process flow. Simple enough, and you have it so it's repeatable and people know what it is. This is like a 1/10 of what my process is at City. Some of these things are on the left. Can you, like around here? This is kind of an end-to-end of the threat modeling. You have your inputs and outputs and things like that. This is a data flow diagram for a service. It's probably a bit more intense than most of you are used to seeing. because it's every API action. It's trust boundaries. It's threats overlaid. It's a lot of things involved in that. This here is kind of a larger process of outside of my threat modeling process. Where do I exist in? And a lot of these is how do I demonstrate, when I told you about the behavioral testing, I need to demonstrate that. All right, I know pretty much getting to the end, I wanted to save room for questions. Whether it's a simple or complex process, it's kind of up to you where you want to be and how mature that you need to be. I think a lot of the things that you might consider in a threat modeling program and how you can move more quickly into the environment, reduce your time to market metric, are going to come from increasing your maturity in this type of process. So with that, I mean, if 200,000 plus person company globally can move to cloud in 2 weeks for a lower level environment, but that's something I think any company can do. So I'll leave room for questions.
Do you have more of the detail in this process you've established publicly available? Something like that?
It's something I'm working on being able to make that public. As this has been regulated, I can't talk too much about our details internally because then I'm making public statements about our infrastructure and other things like that, and we're not allowed to do that.
Well, generic.
I'll let you know I am working on that, and I'm trying to release a paper for that to have a lot of details around this. Overall, I mean, what specifically are you interested in from a process perspective?
Well, all of it, but in more like actually broken down the specific details. Okay, you're saying you're providing pre-baked Terraform modules. To what level of detail or scale? I mean, is that actually the security department writing that, or is this the development teams who bake those, who then collect in a repository of established accepted best practice modules that the developers will modify it, bring it through?
No, that's a good question. The Terraform module one, I'll address that one. The controls are built by the security engineering team. We partner with our infrastructure organization and build the Terraform module because typically it's infrastructure that's going to own the service, because from an operational perspective, they have that responsibility in our organization. And they will maintain the repo and change as things change over time, all this other stuff. It kind of flows back to the process. But that is just, the repos are known to our developers and lines of business, and we advertise that this service is available. Here's where the repo is, things like that. In our threat modeling process, when things are getting threat modeled, they actually, instead of it just being like a paper report, it shows them in the diagram where the problems are. It integrates with our Jira. And so it just creates all the Jira tickets with, this is where the module is, this is the policy that's applied to it. We map out to attack or other frameworks that we use to cover all the types of technology. And so all the contextual information is available to the developer in the ticket. And that updates our diagrams as they close. Does that answer? Cool.
How do you assure that the development teams are using those?
Signature checks, so pipeline preventative controls. And then also nobody has access to the console or what does Azure call it? Portal. GCP is console too, but yeah. Everybody assumes roles, everything's pipeline based. Yeah. Any other questions? I worked out a bunch of questions that I thought would be things people would want to know. Oh, sorry.
That's okay. When you mentioned the end-to-end encryption that was broken, what was the fix? How did you?
Amazon had to fix it.
Amazon.
This is, again, that shared responsibility model, but we were able to detect that it wasn't happening.
Right. Okay.
And so we put in our PFR and complain a lot, and then it gets fixed.
Right.
So, yeah.
What's the process like if there's, say, AWS comes out with a new service that you're developers want to use? Is it this same process to get those Terraform modules and everything else approved?
It's the same process. The way for that component of our process, I purchase content from a third party. I just did a public talk with them in California. They're called Trust on Cloud. And they basically, one second, and then they basically pre-threat model a lot of stuff. They don't cover everything, but it's how we do that to our lower level environment, because we've already built a lot of our guardrails. Now it's just, what are the really critical things of this new service? We'll be able to load controls for them and then enable it for the developer to see, does this really do what I want? Yeah.
Your question, whether do I need a different threat model process for like app versus infrastructure versus cloud? Like if it needs to be different, like how do you handle it when your like code bases are infrastructure as code?
Right, so I have argued a process is a process. And if you have a good process, you don't need different processes. That's why when I was mentioning attack or CWEs or other frameworks, that can cover app, infrastructure, other. And it's the same process though, because really I need artifacts that demonstrate that I've reviewed this and I have a common vocabulary on how I represent what threats are. Really focusing on threats, not risk. That's another big thing. Threat modeling is about threats. It's not about risk. Risk is a different function. And then the controls and the output of that. So what does that look like? And then in your overall process, not just threat modeling, where do you fit into that from gates or artifacts? Anyone else? A lot of the challenges of starting this out is buy-in. What's the value of this? I think overall threat modeling, I had a slide on that, kind of what the things that you can demonstrate through threat modeling, but just talk about not necessarily the outcomes and all that stuff. Talk about why don't we want to know what threats exist in our environment? Are we okay deploying infrastructure or applications without asking questions about them first of how do they work and how does it really integrate? Because when people do drawings and they come into us, they used to come in as stick figures. And it was, this is me, this is the cloud, that's the internet. I'm going to put an application in there. And that was pretty much the gist of it. I'm sure you've all experienced that. Now we have a well-defined process of how to create those and what things need to be answered in that diagram. So we have all the API actions, we have trust boundaries, we have the ability to show common reference architecture. So that's another group I manage at Cities. So we don't have to have novel representations of architecture or just they completely omit it. They just drag and drop into our Confluence shapes that we've already pre-built. And those are also in our threat modeling tool that have all the threats already done. So we don't have to keep redoing things. And so now instead of my core team of about 8 threat modelers, I've expanded to all of our lines of business. And by the end of next year, we'll have hundreds of threat modelers because we've trained them and they don't have to be as experienced as us because a lot of the base stuff is already done. So like app dev people could threat model their own work. It still goes through the process, but a lot of the work's already been done. And so therefore they can show value by, look how much quicker we move. So, all right, the gist of this is, not to focus so much on threat modeling, but just the how to move faster to market with threat modeling. So, does anybody this is bullshit? I don't believe you. So, if there is, that's fine. Happy to talk about it and kind of show you more detail when I'm not being video recorded. So, but yeah, that's yeah, we could all go to lunch.
Mostly empty, which is what. Overpowered, but you know, pretty nature.
That and the bottle opener on the back they have on them. All right, we're gonna get started. I know the lunch line's pretty long. People can just come in and interrupt. My name is Joel. I'm a principal DevOps engineer for a company called Research Innovations. Big long background in web development, switched over to operations side of the house. Been doing that for about a decade now. Print is really tiny. I'm a terrible learner through lectures. If you guys want to talk about SSO, IAM, AWS, DevOps, or even speaking at this conference, I'm very lucky. This is my third time doing a talk with this conference. Email me any word you can think of, 2023@joel.codes will come to my inbox. I have just a regular expression set up, so anything you want to send that way will work. Happy to converse with anybody. So we're going to start with what is SSO. I feel like most everybody in this audience is already going to know the answer to that, so we'll buzz through this quick, right? Single ID for all your applications and things of that nature. It's by nature authentication, but not authorization. So who you are, not what you're allowed to do. Besides a single ID, you also have a single source of credentials, right? So it's like the equivalent of a password manager. So in a large enterprise organization, you're not resetting passwords on 27 applications. If somebody forgets a password, you're resetting it in one spot. There's a couple protocols used to drive SSO, but the biggest is SAML. It consists of a client, an identity provider, and a service provider. The client is you yourself, the end user. The identity provider is the person who can prove or who you can verify you are who you say you are. The service provider is the application you're trying to use. So in terms of an environment, that service provider might be something like Jira, GitLab, AWS. Your identity provider might be backed by AD, Okta, a different identity provider of your choice. Essentially, the way it works is it's a pretty common scheme we see implemented in a lot of different ways now. But once you authenticate, the identity provider signs a token proving who you are. So the service provider can take that token, go back to the identity provider and go, did you sign this? Yes, I did. And it'll have a timestamp in it of when that token expires. Move on to the next slide here. So there's some benefits to using AWS SSO, very simple staffing changes. So you start getting into bigger companies where IT onboards, offboards, things like that. It's really annoying to have to deal with constant change in staffing. But additionally, some of those staffing changes are sensitive. And so having timing, when do you let a DevOps person know that somebody's being let go? How far in advance can you do that? And also emergency staffing changes. You can completely remove yourself out of that loop. The compliance requirements are amazing. Things like 2FA, password strength, all of that. They're no longer on you. They're on the identity provider. So as long as you're not using AWS as the IDP, that becomes somebody else's compliance problem, right? How many of you guys here do role assumption? So if you need to pop between accounts, you've got an assume and a role, and then you can get into that account. And in the web UI, it's in that stupid toolbar, and you've got to have a wiki page with what roles you're allowed to assume where. At the end of this thing, this legitimately takes 10 or 15 minutes to implement. That all goes away, role assumption, all of that. You don't have to distribute roles to all these separate accounts. You can do it all automatically through AWS SSO. It's so nice. The other benefit, of course, is no long-lived API credentials, right? No secret key, access key. They expire they last up to 12 hours and expire. So that's like another compliance benefit. So when you offboard somebody, it's not like where all of their credentials been baked in. Did they bake them into some third-party integration? Your developer just can't do that. You can still get those temporary credentials, but they expire. So it's kind of another way to enforce best practices inside of AWS. So the biggest question is, I keep talking about an identity provider, the person who decides who's who. AWS SSO can serve as your IDP or your identity provider. Anybody have any guesses why you don't want that? Well, one, you don't want to be in charge of that problem. Make it somebody else's. But two, as you start integrating other applications, the ease to integrate those applications it's far easier in other
other services like Okta can help you integrate with hundreds of thousands of applications. But if for some reason you have an exec who comes in one day and says, we're shifting to Azure or GCP, like then you're going to have to like have people sign into AWS to get into Azure until you do the cutover. Also, if you have billing people or salespeople using like Sugar CRM, having them sign into AWS to get into Sugar CRM, like it's all a very weird flow. So it's a little bit more comfortable for most people to start with like Okta or another service like that. So this next slide plays into why you may not want to use something like Google can, if you pay for Google Apps, they can be an IDP, and Microsoft can as well. SCIM is a way to provision users. So I'm going to go over integrating with Okta. So what happens in Okta is you add a user in Okta and it'll just automatically show up in AWS. If you use Google as your IDP and you add a user, Google doesn't support SCIM. They think they know better. So what you end up having to do to use Google as an IDP is you have to have an event bridge function that runs every 5 minutes, which calls a Lambda, which calls into the Google API and dumps users and then go and stuffs them into AWS SSO. Believe it or not, Microsoft has it slightly better. They have an app engine and they run an application that implements SCIM. It's not baked in.
Should just use like OpenID or SAML to do that?
So SAML doesn't do the provisioning. It does the authentication. So SCIM is the provisioning, right? So when you integrate with SAML, it doesn't always, it's a pain. Some applications, there's different ways to implement it, but primarily, yeah, SCIM is like, so it's an IETF task force, you know, Internet Engineering Task Force, RFC, and there's just rough implementations of it. But I think Okta has like 70% of the market and they support it really well. So we're just gonna fly through getting set up with Okta as an IDP using AWS SSO. I have a bunch of screenshots, things like that. So we're gonna run through that really quick. It's as simple as enabling Identity Center in AWS. If you're not using AWS organizations, it will prompt you to enable that as well. So pretty straightforward, just some buttons you can click to do that. This is not readable in this format. It will be in the slide decks you guys can download. You get a lot of very useful information, both on the AWS side, and you get a fair amount on the Okta side as well. So in Okta, it's as simple as logging in, going, I have a new application that I want my users to be able to use when they sign into Okta. You pick AWS. There's values on the Okta side, you jam into AWS. Values on the AWS side, you jam into Okta. The one interesting thing we'll cover is there's a certificate that talks about like to secure and sign the tokens that are exchanged. The thing to know about that is it expires every year. So that's one thing you have to maintain, although interacting with SSO once a year is far better than hiring and firing going on weekly and daily in some organizations. So just start by adding that integration in Okta, and you can just label it however you want. In this case, I have it saying AWS IAM Identity Center. I work in an organization that has commercial AWS and GovCloud, so we label them like that for the users to find. And in this page, you can see where you can grab a token out of AWS, and you can grab this SCIM endpoint URL. I have a very, very important slide coming up that will talk more about that SCIM URL. Let's see if we can skip to that. So this is the one thing to take away from my talk. If you're integrating with Okta and AWS, they give you a URL with a trailing slash on it, and you will get back an AWS error, which, as we all know, means nothing. Like, it's just indecipherable. I think I spent 4 hours on this. You pull that trailing slash off and everything works easy peasy. This is the error you get. That's, doesn't match the pattern, but it doesn't tell you what the pattern is. So here you can see when you're assigning the Okta app, you want Okta to create users for you update user attributes and deactivate users. That's really critical. That's what it's using that SCIM for. So anytime you create a user in Okta, it'll create it over in AWS. Deactivated users is really cool. Users still exist in AWS, but when you go in and look at AWS SSO, they'll show as deactivated. There's a status column, and that helps in IT compliance because there's fears from IT departments like, is this user's access actually revoked? And it's easier to, it's more comfortable to see that the user's deactivated rather than just disappeared. I should back up, and something I should have started this whole talk with is I keep saying AWS SSO. I've been using AWS for a long time. It's IAM Identity Center. If you type SSO in the service bar, it still matches. That was its old name. And you might wonder why I'm showing you guys a lot of screenshots of GUIs. AWS IAM and Identity Center, or the artist formerly known as SSO, does not have strong APIs. So a lot of this configuration step is all click ops. It's terrible and it stinks. When they renamed it from SSO to Identity Center, they added more APIs, but none of it around the initial configuration and setting up. All the APIs were around some of the details we'll get into coming up. So this is configuring the CLI, which I think is pretty cool. So over here, there is a URL that you get when you look at AWS SSO. All of your users can sign into the web UI. They can get this URL. And then when you come over to the configure side, it's pretty straightforward. I should say in front of the microphone, you enter in your configuration URL, the region, and it actually will prompt you with the various accounts and roles you have access to. So it's very friendly for anybody to get up to speed developer-wise. So anytime they call AWS configure, it will on the fly display all the accounts. Additionally, like if you're an administrator on AWS, it's best practice to have read-only access. So you're not logging into other people's accounts with destructive permissions. So it'll show you the various IAM roles you have access to when you sign into those accounts. The old days, we'd all have a wiki page somewhere with like, run AWS configure, enter this value, go get your access key, go get your secret key, make sure you're rotating that every 90 days. We have a Lambda to enforce all of that just goes away. You can just always just call AWS configure SSO to get set up. And like I said, there's a 12-hour timeout. Credentials expire, and all you have to do at any time is type AWS SSO login. This little piece here that you see, a couple things to note. You've got to be running version 2 of the CLI to use AWS SSO. If you're like me, you still want to punch Bezos in the kidney because they have not and will not distribute the CLI using pip. And so it's a binary installer and copies files around, and it's like, are you freaking kidding me? So my initial reaction was to use a Docker container. When you use a Docker container for the CLI, it cannot launch a system browser for you, right? You're off in a walled garden. So if you're running it in a walled garden like that, you're going to have to copy this URL in, enter the code to finish the SAML lifecycle, which happens through a browser where it redirects off to the IDP, you verify who you are, and it comes back. If you're running it on the local system, not in a Docker container, your browser will open up, your default browser will open up, pop to a page. It'll automatically put the code in for you, automatically submit, and you'll have one button to click that says, yes, I'm cool, let's do this. This can be a painful flow if your organization doesn't require people to sign in once a day. But at a company like mine, where email and Slack and everything else is wrapped up behind Okta, and we require people to sign in every day, you sit down, you get through your Okta flow, you do your MFA, you check your email, and then when you go to work on AWS, you just type AWS SSO login, and it's fairly hands-off. You're not searching for your phone, your MFA app, you're not typing codes. That's really, really handy. So we talked about authentication. So authentication, as I said, is mostly handled by SSO. But it also helps out with authorization. And I believe that's one of the big reasons behind the name change between SSO and IAM Identity Center. So the big workhorse in SSO is permission sets. So permission set is just a way of grouping key components. You have users and groups. So groups also can be pushed out of your IDP. So if you've got AWS admins, junior admins, high trust developers, low trust developers in groups, you can push all those groups automatically as well. A permission set also has accounts, AWS managed policies, customer managed policies, inline policies, and permission boundaries. Permission boundaries is kind of an advanced topic if you guys haven't played with that before, so we're gonna skip that one for this. But one of the things I want to discuss when you're creating a permission set is users versus groups. Which one do you assign to? Well, groups, always groups. Don't ever assign anything to a user. Again, one of the big features of this is so that IT isn't bugging you. If IT knows what groups to put people in, you're good to go, right? You have your baseline permissions defined. So you as an AWS administrator are only handing out permissions to groups. If you assign it to a user and I get fired and my replacement comes back in, then you've got to get in and Terraform or CloudFormation and run all this stuff. Just skip it, just use groups. Accounts, use your best judgment. That's up to your company's decisions. You should be in an organization, you should have multi-account level access. I use, for example, like we have a billing group, they get access to our main account in the organization because that's where you have to go to see the billing. They have limited permission there. We don't give them wide access. It's very easy to just list out which accounts they have access to. Oh, this is a big one. Takeaway, skip the AWS managed policies. They're preset policies. They're ones that can't be edited. Don't bother. Your next choice, again, if you're just getting to learn this and you're clicking around in the UI, the next option you'll see is custom permission sets. That's where you want to be. Always go there. And you say, well, you said skip managed policies, and then you say AWS managed policies. Well, there's a difference between the two. There's managed policies in SSO, but the managed policies under the custom permission set is what you expect. Those are like the AWS default administrator access, AWS default read-only across every resource, things like that. The benefit of those is they exist in every account already, right? Every time you spin up an AWS account, there's an administrator access IAM policy. There's, read-only every service, read-only S3, things like that. There's customer managed policies and there's inline policies. So customer managed policy is a policy that you define. So we're back into that kind of IAM assume role nightmare where you have to have the policy existing in the account before you can use it in a permission set. So if you have a policy that says AWS Midwest Community Day demo policy, and you put it in a permission set and you spread it across your organization, if it's not in that account, you can't sign in. So you have to use Terraform or a tool like that to deploy that policy across everywhere. Inline policies, on the other hand, you can define in the root of the org. So you're saying, I have this permission set, I have group developers, and I have account development, and here's the policy that I want you to deploy for me. It has all the limitations of an inline policy, but you'll almost never have any issues using that. The big reason you might want to use a customer managed policy over an inline policy is if you're in a shop like mine, my philosophy is AWS as a service within the company. So I don't tell you how to run AWS. I set you up with an account. I give you admin access, and then I install all kinds of compliance stuff to keep you from hurting yourself. But you yourself are in charge of your account. So if you're on the Volvo car sales team, you're the admin, you own that account. And if you want other people to log into your account, you define that policy and let me know what the ARN is. And I can push out a permission set that says use that customer managed policy for that group of people. It's a really handy way to share that responsibility boundary. This is my personal AWS account. Try not to laugh. When you sign into the web UI using AWS SSO, you get presented with just a square box up top. You have to click it. It doesn't expand. It's annoying. If you're crazy enough to use AWS as an IDP, there'll be other boxes for other applications up there. That's why this doesn't expand. But as you can see here, they all start minimized and then you have to click again. And then you can see the name of the role you have. The pound changed as the account ID. The administrator access below it is the role. What's interesting is you can click management console, will take you right into the web UI. You can get to work. There's none of the assume role. Remember the role name, find the account ID, all of that crud. And then if you need secret key, access key, that kind of thing, it's hidden away. You can just click command line or pragmatic access. It actually spits out like a full page guide. Here's how you set your environment variables and use these keys. And by the way, they only last for 12 hours. So it's kind of handy. So it looks complicated. It's really not. And that's why I was saying, like, legitimately, just send me an email if you're taking this on and you just want to bounce ideas or talk or whatever. I'm happy to discuss with any of you. They very strictly say don't live demo anything. I wish they would have let me. It takes me under 10 minutes. The good news is if you're going to use Okta as an IDP, they do free trials. Sign up for one, throw an AWS account on a credit card, practice. It's very easy to get the two talking. Any questions? I went really fast. I'm just trying to cover as much as I could.
Kind of related, so like a lot of breaches recently, like LastPass and a couple of the major ones were like session hijacking, where like someone's cookies got stolen and they might use it to either go directly to the account or to the SSO. Do you know of any, like, if anything, because from what I understand, like basically once you're logged on, there's now anything recognizing IP addresses or recognizing like multiple logins or anything. Like, so basically there's something to recognize using the same cookie twice. Do you know of any like mitigations for that? I should be technical with that.
So I'm not a security guy. I've had a few security good luck things on my resume, but if you're trying to protect your AWS account from outside access, honestly, the simplest way, and I hate myself for saying it out loud, is your IAM policies, or even at SCP level, just restrict access by IP range. And everybody goes, oh my gosh, how are we going to keep that list up to date? Well, it's straightforward. You require a VPN. So all your traffic to AWS comes through 1 or 2 or 4 endpoint IP addresses, and all other traffic simply gets denied. Because with IAM, a deny always applies before an allow.
Can you restrict it? Like, I know with like Okta, you can restrict it to like specific company on device.
I am a senior solution architect with AWS. I am based in the Cleveland, Ohio area. Been with AWS for almost 3 years now. And one of the things that I've really been interested in for really my whole career, which started as a software developer, is about the move to DevOps, about agile software development, and about ways that we can, with technology, change the way we work for the better. So today I'll be talking about how to enhance your DevOps practices using AWS tools, primarily CloudWatch. So we're going to talk about DevOps, talk about application performance monitoring. I'll go through 5 foundations for success, and then we'll talk about the CloudWatch APM tools that you can use to do this in your own workloads. So what is DevOps? Anyone have a definition they want to share? There's only probably one for every person in the world, but does anyone want to hazard a guess? Or share your definition?
People that take care of the servers in the cloud.
Okay.
I'm a front-end engineer, so that's all. That's
What's that?
I'd expand it to infrastructure.
Yeah. Okay. Agree with both points. It's about, but it's about the tools, and it's about practices, and it's about philosophies. And so DevOps is a combination of new ways of working, new ways of approaching work, and bringing traditional disciplines of development and operations together. For a DevOps approach to be ultimately successful, I think you have to pay attention to all of these areas. So what are the philosophies behind DevOps? Removing barriers, letting people do their work without being hung up, making sure that they're productive, but also making sure that operations are running. So you don't want to take your eye off of the operations to focus only on development. We do that by encouraging communication and by giving ownership. So servers, good question. Who owns servers? Maybe everyone owns the servers in some way, right? And so we want to start to bring these philosophies into the ways that we work. DevOps practices then support this by giving you an ability to automate and streamline. You also want to focus on decoupling systems that can get large and difficult to manage, to troubleshoot. You want to focus on small and frequent software updates rather than large releases that take months and months to happen. You want to focus on small incremental updates. Another practice is managing your infrastructure as code. So before the cloud, you knew you needed servers for a project, they got ordered, someone set them up for you, and you were off and running. But now, as part of cloud development, we need to build the infrastructure as part of our code base. And ideally, we're going to shorten the amount of time that it takes to build and release software. Lastly, we want to make sure we're always logging and monitoring performance. It's going to be important, again, not to set your applications in production and forget about them, but to incorporate the monitoring and operations into your day-to-day operations. So what tools help with this on AWS? Code pipeline, code deploy, code build, and associated tools are all going to help you with CI/CD pipelines. So when it comes to writing your infrastructure as code using CloudFormation or using Terraform, code pipeline can be used to run a deployment pipeline so that while you're deploying your infrastructure, it's going through a controlled and measured process. AWS Lambda had a bad week, but it's a real key to some of these processes. As you know, you can write one-off pieces of code that they might interact with your code pipeline, they might interact with your live applications, they might be interacting with AWS APIs to give you feedback on or to kind of connect the pieces together within your software development lifecycle. CloudWatch and X-Ray, of course, are going to give you your logs, your metrics, and your traces, and allow you to get deep information about your applications. All this tooling is important. We're discussing this over lunch, but the tooling has to be there for you to get a value out of it. And I've seen many cases where the interest in metrics, logs, and traces comes up when you run into a problem and you need to resolve it. And now you're backtracking and saying, okay, how do I get this information? How do I prevent this from happening again? And what we want to do is look at incorporating this tooling into your development process from the beginning so that you have all of these tools in place. So put all these tools together and you get a concept called application performance monitoring. I'll spare you from asking someone to define this, maybe even more nebulous. So there's a lot of tools, there's a lot of tracing, diagnostics, there's now artificial intelligence and machine learning in tools like DevOps Guru. But what is application performance monitoring really? I think it's just about monitoring the end-to-end customer experience. So monitoring infrastructure is important, but in the end, it's our users and our customers that we want to put first and foremost, and use these tools to stay in touch with what that user experience is. And that's going to be in many different levels and layers. There's not just one approach to this, right? So if we look at the layers of observability, we'll start at the top with digital experience, which is that user journey, and it's being able to track the interaction between a person and your system. The network then is everything between your resources and your users. So getting visibility into that traffic becomes necessary when you know someone on the other end, one of your customers, is experiencing issues. where is it happening? It could be anywhere between them and AWS. The network side is about that in-between area. At the application level, you have a collection of resources. You have app servers talking to web servers, talking to database servers. You have queues and event buses, and modern cloud-based applications have many different components. The application layer is going to tie those resources together in their meaningful groups that they work within, so that if there's issues within a particular application, you then have visibility into all of the different components that make that up. And infrastructure, of course, is just our servers, our networking, our individual compute and database and so on resources that we have set up on our account. We know we can monitor individual metrics like CPU utilization and memory and network throughput. But then using all of the layers here, we're going to get a full picture of observability. So we'll come back to the tools. I'm now going to go to 5 key principles to keep in mind as you try to build out your DevOps culture. So first thing, I've talked about customer repeatedly, but focus on the customer. I'm sure everyone's been in some kind of discussion where you're debating, should we do it this way? Should we do it that way? Does it make sense to use this approach or that approach? And I think the best way to get to the end of that debate is figure out what makes sense for the customer and what is going to help to better that experience. So focus on the customer, not on pure technical goals. Leverage automation, transparency and communication, culture of accountability, and having a continuous improvement mindset. So I'll walk through a few points on these 5 areas, and then connect back to the tools and services you can use to realize this. So how do we gain alignment by focusing on the customer? It's by measuring the digital experience. So your real user monitoring, your any kind of web analytics, ways that you can understand if people are experiencing problems in any particular area, or using synthetic testing so that when you don't have users on the site and it's the middle of the day, the middle of the night, whenever you're alerted, even though you don't have real users on the site, because your synthetic testing is going through the workflows that a real user would. Feature flags and soft launches are another great way to be able to get features out there and then gauge their usefulness, survey users, watch users, and you can use feature launches to roll out the changes to a small part of your audience, measure them, and then test different features across different segments. So you might want to try a particular feature out and open it up to 10% of your audience, but then measure and make a decision on how you're going to move forward. There are tools within CloudWatch that will allow you to manage this, the feature flags and the launches, and run experiments where you can watch and see how users are working with your application. Leveraging automation. I mentioned synthetic testing. I think this is a hugely useful point. If you haven't used synthetic testing, it is a headless browser that's going out like a user would and interacting with your site. You can click buttons, you can go through menus, and if you're familiar with Selenium or Puppeteer, those are the testing frameworks that Synthetics is based off of. So you can test your user interface, you can test your REST APIs, you can just test the basic connectivity with a heartbeat to monitor the site. Simplest use cases, you can run a heartbeat check once an hour, and it's just going to say, yes, I got a response from this URL, so your site is still up. We should share that with our biker from this morning, right? That would tell you that your website is down before you log in to find out that it's down, right? Internet performance is a huge area of focus for Amazon because of the e-commerce network and the need really to be able to reach customers anywhere that they are. Because of the vast amount of effort Amazon has gone into measuring the internet performance globally, you now have a tool called Internet Monitor in CloudWatch that allows you to see the interaction between your system and ISPs. It will highlight where you're running into problems in specific segments of the internet. If you were running some type of mission critical application that needed to have 5 nines of uptime, and you had redundant internet providers, and you wanted to be able to detect when one of your internet providers was having degraded service and be able to switch over on the fly, this is what Internet Monitor provides you. Definitely for larger scale, global, mission critical types of applications, but it's a huge benefit because the amount of effort and money it took for Amazon to build is really not feasible for most companies, and thus the service was just launched at reInvent last year. You can collect your fine-grained metrics and logs for your AWS services. Many of them are naturally emitting metrics to CloudWatch. You also have the ability to publish your own metrics. And if you're not doing this already, it's always a good idea to route your server logs into CloudWatch logs so that you can then build filters on them. You can alert off of things like a specific error message on your Apache web server. You now have that ability to spot that centrally and alert. The goal with all of the automation is to be able to move faster. And I think that's one of the keys of DevOps. It's the cloud and the value you can create is really diminished or eliminated if you move slowly. The benefit is to be able to use these tools to identify issues quickly, reduce your mean time to identify them and to resolve them. So transparency and communication. I think people think about dashboards or status reports, meetings you go to and talk about what's going on. And I think the number one thing when it comes to communication is actually alarming. It's not common for people to sit around all day, just looking at your dashboards, right? You're not waiting to see something come up, but you need to use that as a way to investigate more fully when you receive an alarm, an alert that one of your thresholds is breached. So in addition to giving this transparency, it's important to think about what your thresholds are and not wait for something to stop working to realize, but really focus on stress testing and performance testing your application as you're building it, set those thresholds, build your alarming in, and then you have the central source of operational data. You can also route the incidents that you identify into Systems Manager Ops Center. We do integrations through EventBridge to many other systems. You can feed into your own ITSM system like a Jira or ServiceNow. So part of that transparency is if you're used to using tools outside of AWS, then that's fine. Take the data and the information you have, get it into the tools that you need. And if you get it into your ITSM system, you can follow that through as a ticket. It will help to get this type of transparency and quick response like you would expect with any type of ticket that gets put in. This is just going to be automated. Accountability is a big part of this DevOps concept, because the idea that I built it and my job is to build it and I don't support it or operate it it's not good for the customer, right? It's not best for the end result. And my experience as a developer is if you're building something, you want to own it, right? You should take pride in it. And part of writing software is that it has to work, right? So even as a software developer and software development manager, I like to put the onus for test case development and execution on the developers. People are probably used to unit testing and doing things like that within your development environment, but think about synthetic testing the ability to say, okay, I want you to write a web-based test that clicks through the functionality, demonstrates that it works. We're gonna include that test case in our code base. It's going to go through our CI/CD process. You can run those test cases automatically as you're building, track and publish the results, and then give that result back to the people, the teams that built it. So you want to group the results, the canaries, in a way that matches your organization. So group these by teams, by business function, by the customer workflow, whatever way you align as an organization, attach those teams to the results that they're generating, publish them. You can make it more into, I think it's important to make it a positive thing, right? We want to achieve 100% quality. It's not about the negative aspect of something failing. It's actually the point of this is that you want things to fail in development, not in production, right? So last point of this is continuous improvement means you're constantly looking for ways to improve. You have a variety of metrics and the ability to do tracing to help you identify bottlenecks and where your performance has degraded. We have real user monitoring and A/B testing that I've talked about. And so I like to look at continuous improvement by having a separate backlog, essentially, of your improvement initiatives, measure them by customer impact, and then seek to constantly include those in your releases 1, 2, 3. I think the idea of continuous improvement means it could be as simple as every sprint you do, pick one improvement and if you, as I'm sure you know, you let these problems build up, it becomes much, much tougher to resolve them. Leveraging these tools from the beginning and focusing on that constant improvement will lead to, I think, better long-term results. So the tools, back to our stack that aligns here. On the digital experience side, you have Synthetics, CloudWatch Real User Monitoring, and Evidently. The network side is Internet Monitor. On the application side, you have X-Ray, CloudWatch Service Lens. The Insights features as well are kind of pre-built dashboards that encompass the concepts like container versus Lambda that you see here. And then our low-level infrastructure monitoring, the foundation of all this is our logs, metrics, and then the alarms and dashboards that we build off of this. So there's a lot of tools here, and I don't know how familiar everyone is with them, so I'm just going to go through a few semi-live demos here. Synthetics canaries are going to be listed, and you can group those. As you can see here, you're going to see performance over time. You can then drill into the results. You can see screenshots, you can see your logs and your traces all attached. And you can, again, alarm off of failure. So what this can do is alert me that something that I did might have released has impacted the application, or there could be some outside impact. Whatever the case is, we know that some user interaction or what a user would be doing is not working. So this is Synthetics. Real user monitoring looks very similar to web analytics packages you have probably used. This is great to narrow down what are your actual users experiencing versus a synthetic test, which is all really originating from the same place on AWS. The user monitoring is coming directly from your users. It's also incorporating your client, like your browser. So is this a Chrome, Safari, Firefox? And you can then see a lot of detail on each request and identify performance problems that may be specific to the application, or they could be specific to the location or the browser of your user at the time. This is Internet Monitor. You can see all the different networks that are being monitored in this case. Internet Monitor will look at your application and the traffic. It'll understand where your users are come from, and then it will monitor the networks accordingly. You do determine how fine-grained you want this to be. The higher level checks you run are going to be more cost-effective. You can monitor this down all the way to the city level, like 10,000 plus points of data, but then the cost will adjust accordingly. So you really need to figure out if this is meaningful to you, at what level you need to be able to monitor at. This is going to allow you to do your feature launches and your experiments. So you can see in this case, there was a experiment to do an upsell, and there was a new message added in a shopping cart. And this is tracking to see how many people clicked on this button and accepted the upsell, so that we can measure the success of a particular offer or not. So we see here the events over time, the variation. Then you can set the split of traffic, who you want to see what version. And then if you decide you want to go ahead and launch, you can do that with one click, and then the feature is live for everyone. Service Lens Map is my high-level picture of my components and their interaction. So in a large distributed application, you have your web servers, your database servers, you have ECS or EKS clusters, you might have SQS queues. There are the supported services here. API Gateway is another one. We'll build this map automatically for you. It's going to help to identify bottlenecks in the process. You can see the red highlight on this gear in the middle, and that's telling me that an alarm is going off on that component that I have set, and I can then drill in. This is excellent for looking at the user journey as a whole, because this is showing me the interaction between my different components and if there's a failure anywhere within that. So if you want to learn more and experiment, the One Observability Workshop is everything that you can do with AWS Observability in one place. There is a cloud native section, and I've today talked about all the AWS cloud native services. You also have the open source observability world, where you have tools like open source tools like Prometheus, Grafana, and others that are more like you might use them already, and that's an easy path to build observability. And so all the same concepts apply, different tool sets on the AWS native and open source side. So highly recommend this workshop. We also have an observability best practices site that was just published late last year. It's on GitHub, and it is a community-based effort within AWS. I wrote a couple chapters, and I think a few dozen people have contributed to that. That's a comprehensive guide, and it's not AWS specific. It goes through first just basic monitoring and observability independent of any application or cloud system. The Skill Builder, if you haven't used it, is our free online training platform. And there are there's a good AWS observability series in there. And that is that. Thanks everyone for your time. Let me know if you have any questions. I'm happy to answer. Yeah.
I mean, a question on the container insights on the application performance monitoring.
Yes.
So do we need to just enable that feature, or do we need to deploy it? I have things running on EKS. We're using the app and it's for performance monitoring, probably from the app for the banner trace.
Yeah.
The typical API. But how does it compare with that solution? That is one thing.
Yeah.
And second thing is they use the agents to monitor the performance of how they have the teams and other specific track. So how does it work with container? Do we need to install anything or just enable?
So the container insights just needs to be enabled, and then that will feed data in. With Kubernetes, there's two approaches. You need to get you'll need to get an agent on there, like your CloudWatch agent or your X-Ray. That you can do either in as a standalone or a sidecar approach, or you can build it in. I think the recommended approach for that is a sidecar approach. So you just have a pod that's running the tool, and then you can connect with that and interact with that. I know there's, as part of the setup for EKS and monitoring, you'll find online, there's a guide to how to set it up as a sidecar. Yeah. Okay, anyone else have any other questions? All right, thanks everyone.
Good afternoon, everyone, and thank you for joining today. I feel like my talk is exactly a continuation of Rob's talk. Before that, we're going to talk about like cloud DevOps. Well, really, this talk is for security folks who are moving into the cloud. So we want to see like how do we apply security measures in a cloud/DevOps world. My name is Ahmed. I live in Chicago. I work for CDW now, and I manage a team that does incident handling in cloud. So we do that, and then we also develop our own applications. So we've been through this journey of like moving from traditional security to cloud-based security. I also teach for SANS, and I teach the exact same thing. Basically, how do we put all that into the DevOps environment? So with that, this is a very short introduction, right? We're going to talk about what DevOps is really quickly, because you already know that from the previous one. We're going to talk about some of the tools quickly, and then we'll dive into security, and we'll see how does that all tie together. So to begin with, I'm not going to ask you to define DevOps. You already done that in the previous talk, but let's talk a little bit of history. Historically, there was a separation between development and then infrastructure or operations and security as well. So we got these three things kind of separated from each other. With the introduction of DevOps concepts and with cloud making that even easier, things are kind of merging now, right? So you don't have that separation. And if you really think about like the DevOps logo itself, you will see that it has two parts. There's dev, and then there's the ops, which is the operation. And it always starts with, hey, we're going to plan this type of project. We're going to write some code, and that code is going to be built and then tested. And that is all part of what the developers are doing. Sounds good? Once we have that code tested, now it's time to put it in production, right? So we're going to deploy it. And we're going to deploy it. We're going to run some tests. There are certain operational tasks that we want to do. We also want to monitor and measure. And then we want to learn from that and then feed that back in and continue to the development. Hence the name continuous integration, continuous development. Sounds good. So that kind of changed how we do things. And the question is, how is that really related to security and in specific in cloud security? Now, to answer that, let's take a look at some of the major changes, or like one of the major changes that changed when it comes to security. Anyone here from a security, like strictly security background? Yeah, so are you familiar with like the code and how security people hate code? I used to hate code, right? So that's the first thing that changed, right? Now, everything you do is basically code, whereas previously, my first job was a Unix admin. What I used to do is basically go and like rack the servers, physically connecting them and install the operating system, whatever the application team requires. And then I would apply some security because I had a checklist. And that checklist was basically, hey, disable the service, open SSH, make sure that the system is patched, make sure you use the golden image, which was a CD. Now the question is, do you think every time I did that, I did it exactly the same way? Or maybe sometimes I forgot to do certain steps, right? And then once I forget, I would probably remember that the day after. And I was like, oh man, I forgot to do that. I probably need to log in. So manually I would log in to that system, and then I would make that change, right? So now I have secured it. Do you think there was a good way of measuring? So would my boss know exactly if I did a good job or not? Yeah, I see. Yeah. Some people laughing, of course, because for that to happen, there has to be like some level of trust, right? And then once a new engineer comes in, do you think that new engineer will do exactly the same thing that I'm doing? It could be more, it could be less, right? That is changing with code. Now we're using code pretty much for everything, right? So think about from the beginning, racking those servers, that's gone, right? In cloud, you just create code that creates infrastructure. You do not also point and click, right? It has to be repeatable. Once you have that infrastructure, so that is your network, that is your security groups, your VPC, your subnets, all of that, then you build your instances. Once you build your instances, you still need to configure those. So remember me logging into that instance or that server and making changes, that's gone too. Now we have configuration as code. So think about things like Ansible, and Chef, and Puppet. Now there are a lot of tools in here, so keep that in mind. That's one of the challenges. Now that we have that, how about we throw some containers, some container magic into the mix, right? Who here understands exactly how containers work? Nobody? I have some understanding, right? I know that it has to do with Linux kernel, right? And its capabilities. It's a very complicated topic to understand, but it does magic for us. And apparently, as security professionals, we are expected to know that too, right? So that's a whole new area. But also that is code as well. So the way we build containers is by creating this Docker file that is basically code-ish that is used to configure this container. So that's fine. That can be considered code too. What else do we have? Well, obviously we have the application code itself. That hasn't changed, right? The only thing is that now we're more close to it, whereas previously you had to have someone who's an application security professional so that they know what they're doing in terms of application. Those were like a very small number. Now the security professionals have to be closer to that. We have to understand the application code more. One of the things that I recently, well, not recently, but I learned is that documentation is also being done by code. This is amazing, right? You've got tools such as Terraform docs that will go through your Terraform code and it will create a document that tells you this code creates these resources, it takes this input, it produces this output. Fantastic, right? Now, we also have other things that developers are very, very familiar with, but we're not. So these are the automated testing. So it was mentioned in the previous one, Rob mentioned Selenium testing, right? There are different types of testing that developers do. Maybe we can take advantage of some of that. Now, also, all of these different tools, all of these different types of languages, quote unquote, right? Most of it is YAML, so one language. So if you know YAML, you know so many tools, that's great. But then in order for us to have all of that, we have to tie it together somehow. There has to be something that glues all of this together. And this is where the deployment pipelines come in, right? This is the gist of our discussion. So these are tools such as Jenkins, AWS Code Pipeline, GitHub Actions, etc. And these have their own languages as well. If you're unlucky to use Jenkins, you would have to learn Groovy, right? But if you're not, if you're using something else, maybe YAML can do, you still have to learn a few things. So now we look at our infrastructure and all of a sudden it's all about code. And if we do not really know how this works, it's going to be a little bit challenging. And that is something that we see security professionals kind of a little bit struggle with. To illustrate how this works, you get a bunch of engineers, right? And developers and AI nowadays, right? We're creating code and maybe we're using a tool such as Microsoft Visual Studio. All of this needs to be stored somewhere, right? And there's a big history about like where do we store code and what do we do with it? Well, AWS Code Commit could be one tool. This is an AWS adjacent event, right? So all of the tools are going to be AWS, but you don't have to use Code Commit, right? You can use GitHub, GitLab. We got GitLab as a sponsor in here. Bottom line is all of this code being produced is stored somewhere. What happens there? As soon as we put that data in, there would be some sort of a process that will kick off. This process would take whatever that code is, will run through a pipeline, and then eventually will build the infrastructure / application / container images, whatever we are building, right? So now we check it in, there should be a process, and in this case, that would be code pipeline with the help of code built, as an example, right? This is a simplified view. And it will do this certain magic, and that magic will produce infrastructure for us. All right. Anyone has concerns about this so far? Do you see like security issues in here? Let's zoom in a little bit. Let's zoom in on the process of creating this pipeline. The pipeline, if you are using AWS code pipeline, would look something like this. So let's kind of digest what's on the screen. Who have used AWS code pipeline before? Who has suffered using AWS code pipeline before? So we were talking about this earlier, where code pipeline is great because it's almost free, right? It's not that expensive. You could do it if you are a small team, such as my team. You can use it without any headache of managing any other system. It does kind of have some pain points, but it gets the job done. If you're starting off, maybe you can use that. Let's say you're running Terraform. You're using Terraform to build infrastructure, right? You can build it in a way where there are multiple phases, and each phase will do one specific thing or a group of things. In security, that would be maybe you want to run certain security tests, right? So if you look closely, I don't know if you can see this. I'll try to use my cursor. This is the first step, where the code pipeline basically gets the code from. It just clones the code in preparation to do something with it. And you can choose to do certain things. So for example, this new stage is called static code analysis. More on this later on. And if you look closer, you would see that two things actually are here. Checkoff and Hedolint. Both of these are security tools. Checkoff scans infrastructure as code and a bunch of other things. Hedolint scans Docker container images, well, Docker files, right? So you're using this to basically scan your code. So that's the first. How does this work? Well, code pipeline integrates with code build. It creates code build projects, one project for each task. Now, that has an advantages, and it also has some disadvantages. One thing is that this code build project is actually a container, right? So it runs on an image, which means you don't bother if you don't see it. There's another slide that basically will explain all of that. But what that basically means that the pipeline will spin up this container, will put that code in that container, and then we'll scan this code, and then it will produce results. These results could be stored as artifacts somewhere else. So maybe in a bucket, maybe in a tool, we want to create reports, maybe it will send it to CloudWatch, right? I will have to do something with these results. Maybe if there are specific security issues found, maybe I'm going to stop this pipeline, right? That could be arranged too. And that's basically the point of it. Now, code build projects are based also on YAML. There is this spec file, and the spec file has the instructions of what needs to happen inside this container. So again, this container pops up, it scans your code, and then it just dies after storing this the result somewhere. Another one then pops up, does Terraform plan, right? And then it works with that, and then maybe it shut down. Another one pops up and say, hey, now I want to apply, and that's what actually builds the infrastructure. All right, sounds good. Let's zoom out a little bit. Now we understand like this process. And I think this is the most important slide I have for you today. Are you guys familiar with defense in depth? In cybersecurity, defense in depth means that we have different layers of security, and we want to apply those independent of each other. So for example, if I have a server, I need to make sure that server is patched, regardless if that server sits behind the WAF or not. Right? The WAF, the web application firewall, could provide me with virtual patching. So attacks come in, they will be stopped at the WAF, but I still have to assume that that WAF might fail, and therefore I cannot say that, oh, because I have a WAF, I don't need to patch my server, right? So that's defense in depth simplified. This is the same thing, only now we're looking at the DevOps workflow. And you can think about it as these 5 stages. So pre-commit, that's before my developers push anything into production. That is my developers basically writing code and putting it locally. And then I have the commit. That is once the developers hits, hey, get commit, get push, right? So now you uploaded your code, you pushed your code. Once the pipeline picks that up, that's the acceptance phase. I'm going to run these tests that we're talking about. And then I'm going to push that into production, and then I will monitor it, do incident response, what have you. In each one of these phases, there are so many things that we can do. And that could serve as a map, right? So let's talk a little bit about some of these. So pre-commit hooks, right? Under pre-commit. Do I want secrets in my code? What if one of my developers wants to push secrets for some reason, right? Maybe there's a pre-commit hook that will basically provide an alert saying, hey, by the way, your code has something that looks like an AWS access key, right? So that's what that is. We don't have time to cover all of these. So I have chosen one of each to kind of talk about and see like, what can we do with that? So we're going to begin with the IDE security. We're going to move to static code analysis. We already talked a little bit about that. We'll move to dynamic testing, then secrets management, then finally end the discussion with continuous monitoring. So with that, as a developer, as an engineer, or as a team of engineers, I'm using tools to write all of this code and produce it locally. It would be great if there are tools that would actually help me secure it in a way. This is where if you're using Microsoft VSCode, you can use the plugins. And the plugins are basically scripts that use some of these tools that are installed locally. So as an example of that, the screenshot that we have is taken from my VSCode. And let me use the cursor. So this is a security group. And that security group basically is underlined. And when you point at it, this description will happen. And I don't know if you can read it, but I can read some of it. It basically tells us that this security group has some issues. It's a bad one, right? You need to do things with it. So that's me as I'm writing code. This is coming from a tool called CFNNAG. And CFNNAG is a tool that is specialized in scanning CloudFormation templates. If I'm writing Terraform, I will probably need another tool. These tools have to be installed locally on the developer's machine, right? That's the development environment that they're using. Anyone sees an issue? Pipeline? We will get to the pipeline in a minute, but yes. But how about guarantees, right? If I have this, does that mean that developers will actually fix it? I mean, maybe, right? The other thing is, there are so many tools. I mean, this is just this is a sample of them. How do I guarantee that these engineers actually have these systems on their machines? Well, there are so many ways to address that. One of them is basically using Ansible to configure these machines with these tools. So that's one approach. So you had a question.
What I was also going to say is some of these tools require configuration.
Yes, exactly. Yeah. So you have to configure them, right? So that's another add. So who's going to do that? If you have a team of 5, right? Maybe what you want to do is maybe have like one machine, one server, and then everyone connects to it because VS Code has the ability to remote into different machines. So maybe that's one approach, right? So now you have to manage one machine, one development environment, and then everyone else is connected to it. That's one approach. But regardless of that, because we have these limitations, we want to also do the same thing, but now we want to do it in the pipeline. So this is where we enforce things. The previous step, this is more like suggested, right? Hey, you probably need to fix this. So now we talk about static code analysis. And the name static comes from the fact that everything we do, we're doing on the static files. We're flat files, and we're reading these files, not as humans, but as code, some sort of a tool that's reading these files and telling you, hey, you have certain issues. This security group is bad. This is actually the exact same results, only now I'm running CFNNAG on this main.yaml, which is a CloudFormation template, and it's basically telling me, hey, you got this subnet wrong, the security group. I'm doing an awful job, basically. And you also can see that some of these are yellow and some of them are red. And that's the difference between warning and an error. Maybe I would like to configure my pipeline to stop the build if there's an error, right? If there's something that is serious. And maybe I need to have a threshold, right? That says, hey, more than 5 of these cut off, like do not continue. If all of them are warning, maybe just mark this pipeline as unstable and move on. Now, there are certain things that we need to be aware of. One, these tools have to be fast, right? Can I run a static, any type of scan that will take 30 minutes? Does that go against the DevOps strategies, right? I need to do things fast. So that's one thing. I also need to be able to run these tools headless, which means they need to run either command line or maybe through an API call, but not a graphical tool that I point and click. That's all. We don't do ClickOps, right? Do we? So that's the thing. Many of these tools, unfortunately, were developed before DevOps. Now, CFNNAG obviously is not one of them. It's designed for CloudFormation templates, but there are others that are. So this will require some research on our part to kind of decide, first of all, what is the technology stack that we have? And then based on that, what are the tools that are suitable for us to use? These are some of the suggestions, right? So we talked about Hadolint. If we're using Terraform, there are a whole set of tools. And then you also have the OWASP dependency check. That's an important one, right? Unfortunately, we'll not talk too much about that. All right, so that's good. We have a bunch of tools running static code analysis. Everything is fine. Now the pipeline is moving to the next stage. Now the pipeline has built the infrastructure. So now I do have an infrastructure, and I do have maybe some serverless application, or maybe an application that runs on EC2 instances, Kubernetes, whatever you want. And then now that application is ready to be interacted with. And interacted with is the keyword here, because this is dynamic security testing. Now I'm going to interact with this application and sort of do some sort of a vulnerability scan, if you will. I'm going to send requests to this application, and then I'm going to receive results back. This is drastically different from static code analysis, right? Where I do not have an application to communicate with. This will basically uncover things like SQL injections, for example, right? I can still uncover that based on static code analysis, but now I have a more in-depth knowledge. I can test this with it. The same principles apply, but they're more important here, especially the speed one, right? Has anyone here ran maybe SQL map or Burp Suite? How much time did that take? 30 minutes, an hour, depending on the application, right? Sometimes longer than that. Does that work in a pipeline? Not really. So what do I do? Well, there are two things to consider here. One, I probably need to create a solution that is custom to my application. Custom meaning that I want to strip it down and focus on the most important things. Does this also mean that I still have room for something like dynamic analysis outside of my pipeline? Because I didn't run everything inside the pipeline because of the speed limitation, right? So maybe I want to create another deployment environment. So I usually have a dev, maybe a QA, and then I have production. Maybe I can have a QA or something similar that is only for running these types of scans that are time hungry. They're also CPU hungry, right? Resources hungry. So it's not just that the dynamic scan is slow, but it also consumes a lot of resources. So running that in a container maybe is not the best idea, right? So maybe I need to take it off. What about things like penetration testing for my application, right? Does that make sense? So maybe I have the same environment that I've created for anything dynamic, anything that would take time. Maybe I can use that as well for something like a penetration testing, or maybe a more thorough vulnerability assessment for this application. And by the way, when I say application, that includes everything, right? The application itself, the infrastructure, everything I created with code. All right, so moving on. The next topic that we want to pay really close attention to is secrets management. Because there are nothing manual, somehow all of these different systems need to share secrets. So think about the AWS code pipeline when it needs to create infrastructure. Does it have to have some sort of roles involved, right? It needs to have some sort of an access to be able to do that. What about reading code from code commit or GitHub? Does that mean that, let's say, Jenkins needs access to GitHub? How is that going to happen? There probably will be secrets stored somewhere. Are these secrets stored in code? Obviously not, right? We want to do that. So therefore, there are many solutions, secret managers, that can help us do that. And there are different types of secret managers. There are ones that are cloud native. So if you are all in AWS, you have many options. So KMS being one. Anyone uses SSM parameter store to store secrets? We do too for some projects. Yep. Is it fantastic and free? Yep, it's amazing. Every few months we meet, the team and I, and we say, hey, do we have any reasons for not using SSM? And everyone says, no, that's great. I mean, we love it. All right, there you go. So that's one solution. It has limitations, of course. If you want to do things, once we grow, I'm sure that at some point
we will move to something like AMS. What if I'm in both, in AWS, but also in Azure? Maybe I need a different tool, right? So I have a lot of options. One of them is Vault. So Vault is another option that's basically standalone. The pros is that it can basically be your centralized storage for everything. The con is basically you have to manage it. You have to actually work with it. You have to make sure that's actually secure. And speaking of that, does this mean that these security managers are a perfect target for attackers? So it used to be, well, I shouldn't say it used to be, but if you're handling an incident, probably what would happen if someone phishes one of your employees, the next thing that the malicious actor will do is maybe scan your network. So Nmap, right? It's not the case anymore. Probably what they're going to do is find out your sources of documentation. So SharePoint, for example, and then maybe try to find what type of DevOps infrastructure applications you have and solutions you have. So they will find your GitHub, your GitLab, whatever you do. They will find your Jenkins, whatever orchestrator you're using. And then maybe they'll try to exfiltrate secrets. If you are a malicious actor and you land access in, let's say, GitHub, what's your next step? Anyone?
Run through the history and look for secret code.
There you go. How do you do that? You just search for it, right?
There are tools for that.
Yeah, there are tools for that, but you can go and just in the search bar say password and then hit enter, right? And probably you will find something. You can also search for keys. So you can search for something that looks like an AWS key. They all start with the same 4 letters, like they're like a bunch of, I think 10 or so. You can also search for encryption keys, so PGP keys, certificates, etc. It seems like this is a gold mine for attackers. This also means that this is something we really, really need to pay attention to when talking about secret management. So how do we manage that? So that is one of the reasons why we use SSM parameter store. It's much easier for us to secure, right? Roles, and we assign them, make sure IAM is pretty tight, and that's about it. Rather than having a Vault server that now we have to have an expert in Vault, or someone has to learn Vault, and then we basically have to spend time managing this. All right, so with that, finally, the final topic for today, not finally, continuous monitoring. So that's another example of things that we can do within the pipeline itself and within the, not the pipeline, but the DevOps environment itself. So we have pushed everything in production. What if something goes wrong? Do we have, or does the cloud provide us with many tools that will allow us to mitigate these things? So as an example, maybe I would like to create a CloudWatch alert. Then that CloudWatch alert would look for a specific event. And once that event happens, it will trigger a Lambda that will basically counter that event. So block users access or strip user from roles, right? What if I have an instance that I have reasons to believe it's infected with some sort of a malware? I could kill it, right? Within cloud, that's fine. You know that's okay. But what if I need to do some sort of forensics on it? Maybe I can have a Lambda that will basically go in and isolate that instance as an example, creates an AMI image, and then move it to forensics, right? Heavy engineering stuff. Now, luckily, I don't have to do all of this by myself. I could, if I choose to, if there is a specific case that I'm really interested in. But then there are other tools for us. Actually, Capital One created this awesome tool, Cloud Custodian. The screenshot that we have is from their website. And it basically has like a configuration file that we define. And we basically say, hey, when you see this event, take this action. And it's nothing but a bunch of, well, I shouldn't say that, that's like oversimplifying, but in a sense, it's a bunch of CloudWatch alerts that are invoking a bunch of Lambdas to take certain actions. So you create a security group that is insecure, that opens SSH to everyone. Cloud Custodian would have a rule that goes in and removes that entry, and then puts a log in CloudWatch, for example. That was a super fast coverage. With that, any questions that you guys might have? All right, well, thank you very much.
We'll get started. All right. Hi, everyone. My name is Matt Bedanes. I'm from Morningstar. I'm going to be talking about guardrails in the cloud at scale. Unlike what it said on the website, there are no bananas in this presentation. Sorry if you're here for the bananas. I apologize. So we probably could, but All right, so what are we doing here? Why am I talking? Here's a brief outline of what I'm going to talk about today. I'll do a quick introduction about myself and and some of the high level stuff we're going to talk about. I'm going to give you a little overview of our footprint and cloud posture today, and then what we're doing to implement controls within that. And then I'll take some questions if you have them. I'm going to try to, most of this is fairly high level. If there's something you want me to go into depth more on as we get it, just raise your hand and ask, and I can happily go much, much deeper, but I'm trying to cover a lot of ground in 30 minutes. So, whoops, wrong. All right, who am I? I'm Matt, I'm a principal cloud engineer at Morningstar. My focus is on security and architecture. At Morningstar, we have something called Cloud Services, which is a centralized cloud enablement team, which I'm a part of. I've been at Morningstar for 20 years, and the one thing I have learned is don't show your weaknesses, otherwise they show up as bananas on the title for your presentation. Thank you, Margaret, for that, who just walked into the room. Oh, hi. I won't share her weaknesses. Bananas. Yeah, it's 2:30, isn't it? I'm very prompt, I don't know. We generally try to follow these principles with at Morningstar. I think a lot of people do as well. We try to keep things very decentralized, even though we are a centralized team. We want to make sure that our developers and our product teams are able to do it in a self-service fashion when they're doing it. In order to accomplish that, we want to make sure that we have multiple accounts and everything must be as code. So my team in particular, when we lay down our foundations, use Terraform. Other teams with Morningstar use CloudFormation, CDK, whatever, command line, whatever they feel like doing. We're trying to push, especially now, we started out about 6 or 7 years ago doing this. And at the time, people were doing a lot of lift and shift and EC2 instances, and we are now pushing more for cloud native and managed services. And we want it to all be ephemeral. So you're not spinning up EC2 instances. If you're going to use EC2, put it in auto scaling. At Morningstar, this is kind of what it looks like. We have what we call team accounts, that each team represents an application within Morningstar. There's about 250 plus of those. Each one of those is a prod and a non-prod, and then you have your lower environments and your upper environments. We've got 4,600 SSL certificates in ACM. We have 43,000 IAM roles with 27,000 inline policies. We have 12,000 Lambda functions, and the list goes on and on. So with it's not small, at least for us. Our team is not that big, and we're managing all, and we have to make sure that we know what the teams are doing and doing it accurately, doing it well. So how do we ensure that they're following the best practices? A team has pretty wide open controls once they're in their team account. So we need to make sure that when they're doing something, they're not doing it badly. They're not putting an EC2 instance out on the internet with no patches, that they're not, putting, star in for their IAM roles. How do we see it? How do we even know it's there? Because if you put out that account and you don't do anything with it, you're not going to know what's out there. And how do we encourage and enforce the better behavior? Because we have things that are important to us that they may not be thinking about, and we need to make sure that they know about it without just going to them and emailing them, because that's never going to get anywhere. So I'm going to talk about two sets of tools. I'm going to talk about the AWS specific tools that we use, because this is an Amazon conference, but I will also be talking about things that are not Amazon, because not everything works that way. First, I'm going to talk about, these are the things we're going to talk about. I'll talk a little about the multi-tenant strategy. We'll talk about CloudTrail and Guard Duty. IAM Identity Center, SSO, I'm just going to call it that because it drives me nuts. Our use of network firewall and transit gateway, transit gateway and service control policies. Those will be our specific Amazon services. So our account strategy is keep it small. So we've actually been finding some of the bloat lately, but we try to say team, we try to keep it small. We try to keep it within a team. So for example, our team is responsible for laying down the VPCs. We don't make them very big. And if a team comes to us and says, we're out of IP addresses, we say, you've probably gotten too big, time to break apart. We keep them isolated. So even though I mentioned we are using transit gateway, we don't do meshed connectivity. So team 1 and team 2, their VPCs cannot talk to each other over any private link. We isolate them by environment. That just seems logical. As I mentioned, we don't allow direct connectivity, and we make sure that we're using federated login. So as best as we can, there are no IAM users in any of our accounts. First things first, CloudTrail. Any of you who are using Amazon, you probably know about CloudTrail. It's logging it's configured in all of our accounts. We started early enough that we weren't using it on the org level, so we're still deploying it account by account. But since it's tracking every single action that's being taken in the account, it's a really great tool to have. It's really great when someone says, hey, what happened to this S3 bucket? Or hey, someone's doing some anomalous behavior, we can track down those actions. We aggregate into an S3 bucket, and because I think we have about 50 million events a day at this point, we're using SQS because we're sending it to our aggregation tool choice, which is Splunk. Someone else might be using Elasticsearch with Kibana or some other tool. We found that we were ending up, it was taking days for Splunk to keep up. So we started to use SQS triggers. One thing to consider, and I just noticed this is newish, but you can actually get rid of the read-only events, which we did not do. So I recommend either turning it off or be expected to work on your retention policies, because otherwise your index is going to get very big as you're checking it. Guard duty, for those who are not aware of guard duty, it looks for anomalous behavior within actions that are being taken. Common ones are, something's connecting to an unexpected endpoint, there's IAM exfiltration, and so on and so forth. By default, it's using DNS, CloudTrail, and flow logs to find that behavior. But they've been adding more and more protections like S3, Lambda, and EKS, which have come out in the last 6 months or so. And that all can get sent to your SIM of choice, or however you want to do it. We send ours to Splunk also, and then that gets flowed into our operations team for security purposes. So if they see an event, it gets sent to them, and they can escalate it. One thing that we found with guard duty is there's a lot of false positives. Easy example would be we're using Outposts, for better or for worse, and worse. There we go. Well, we're deprecating it, thankfully. But what ends up happening is if an EC2 instance with an instance profile makes a call to Amazon, it looks like it's coming from our corporate IP address, which guard duty thinks is anomalous because it's not theirs. So we've had to do a lot of filtering. I'll talk a little bit about how we're doing that in a little bit. All right, SSO. There was a talk about SSO. I don't see him in the room, but it was a very, very good overview of what it is. But effectively, it allows you to do SAML authentication within our corporate IDP, which, as the previous presenter talked about, is Okta as well. We've done a heck of a lot of customizing of it, because with our 250 accounts, we have 3 standard roles that we put into every account. So what we've ended up doing is we have a Lambda that's triggered by events in which if we see a new group added into SSO, we then go and try to figure out what account it should be attached to. Once we figure out what the account is attached to, we then do the role assignments and the permission sets, because we have standard permission sets that we're stamping out on every account. We've got admin, read-only, and operator are 3 standard ones. But if we have a customized one, we have Terraform, we can push that out as well. So when a new account is created, basically we have a lightweight API that sort of ties account IDs to an internal ID that our company has for these accounts, and then these are all deterministically created. So we can then determine that. Point of reason they use this is federated login is good. Someone leaves the company, they get disabled, and we don't have to worry about it. Because it's using roles, you only get 12 hours for the keys, so the keys expire after 12 hours. So even if someone puts it on GitHub, we probably don't care by the time it gets found. And IAM users are bad. But with one caveat, we do have basically, we call them, they're effectively service accounts. They have IAM keys. It's for things like if you're on premises and you need to talk to S3, we do that, but we make sure that's very tightly controlled and don't allow full open access on that. A couple of things is, in order to make it work for our use case, we had to customize it pretty heavily with our automation. Once it was set up, we don't have to do much with it at all. It's actually pretty slick. A new group appears in SSO, it automatically gets attached to the right account with the right permission sets. I think it was pointed out in the earlier presentation, but yeah, the API maturity on SSO is lacking. It's getting better every week, every quarter, every year, but initially we couldn't do anything with it automated. Like, it had no API. And now they have an API, and there's still some things we're missing that we need for compliance purposes, which require some manual work, which is not much fun. All right, network firewall and transit gateway. I think there's a talk after this about this, so I'm not going to go into too much of it. But when we started, there was nothing like this. We were using peering, and we had to put our direct connects directly into our accounts, which had lots of management overhead. With transit gateway, if anyone was using transit VPCs in the past, it's transit VPC as a service. And an improvement on peering. So what we have a shared services account, which does have peering, and we hit the hard limit. So we couldn't put any more routes into our route tables. So we very quickly pivoted the transit gateway, and it's taken 18 months to get to the point where we are, where it's almost ready to be done. 18 months, was I right on that? Maybe 2 years, way too long. Before that, our firewalling was pretty bad on premises. We were using network ACLs. That made us all very, very sad, but we had budget constraints because of the lack of a centralized egress point. So we added network firewall to that as well, because we're Amazon people and we don't know Palo Alto that well, but we might change that. I'm not, but network firewalls like a managed firewall by Amazon. It has IDS and IPS features. You can use Suricata for rule sets. You can also just do straight up source destination type of work. And we're using this for our egress traffic. So if it's going back to our on-premises networks, or if it's going out to the internet, then it's hitting transit gateway and network firewall. We're finding some teething problems with cost, but we've been able to use the flow logs to extrapolate what the top talkers and start sending that back for chargeback as well. And then service control policies, which I think might be one of my favorite things, because when we started, there was no organizations, and we would lock down the standard roles, but all someone had to do was create another role and they could bypass our controls. So with service control policies, it's like IAM restrictions for the whole account. So for example, our teams are not allowed to create VPCs, subnets, are not allowed to touch the network ACLs. So now we can basically just put a rule on the entire account and say, all right, now you can't do that. And so if someone tries to create a VPC, doesn't matter how they're doing it, they have no way of getting around that. And it makes us pretty happy. You can put that on OUs, you can put that on accounts. We found some there's like a hard limit of 5 policies, and we have more that we'd like to make. So we ended up making nested OUs. So you can put 5 on one OU, 5 on the next OU, 5 on the next OU, which is a hack, but it works. So it's something to keep in mind. So other tools. I'm not talking about this at an Amazon conference. We use some custom and third-party options. These are sort of the 4 high-level ones I'm going to talk about. We have our custom scanners. We're using something for vulnerability management called Wiz. We use Splunk and XOR, and we're using Jira and Brinko. And I will talk about those. So custom scanners. When we started, we looked at a lot of the tooling for some of the common security things we wanted to check for, and we had a few things that were fairly custom. So we instead of using a third-party tool, we actually wrote a lot of stuff. And basically, we've got CloudWatch event. Event Bridge. Within Event Bridge, we've got the event bus, and so actions for we've created a system where any actions coming from any of our accounts get sent back to a centralized location where we can look into them and take action on them if we want to. We also have things that run on a fixed schedule that aren't as pressing. We want to just look at the environment and interrogate it. The tech stack on that is step functions, Event Bridge, Lambda, and DynamoDB. At this point, I think in May, we had 20 million Lambda invocations that cost like $15, which is very cost effective, especially when we were in the early days, we were budget constrained and we couldn't afford the tooling. Some of the things it does, it'll take actions, it'll cut tickets. The easiest one is using our golden image. We publish an image every month that the teams are expected to use. If someone spins up an EC2 instance, we capture the run instances action within CloudTrail. We look at the payload from CloudTrail. If it isn't one of our blessed images, we just terminate it and it's gone. And we let them know, hey, we killed your instance. We do tagging enforcement. So now at this point, if someone spins something up without the right tags, we kill that also. And then we also go out to the existing instances and cut tickets if they haven't tagged their instances properly. We also use it to catch instances that have been out for a long time. We have an auto tagger, so if something gets spun up, we found that launch time isn't very accurate. So now when something gets spun up and it gets tagged with what the create date, and then we use SCP to make sure people can't mess with that. And if we see instances that have been around too long, we cut tickets for it. All right, I'll talk a little about Wiz. It's something new for us-ish, maybe 6 months, and we've been starting to use it. It's a vulnerability management platform. It's also a cloud security posture management platform. So it does 2 things. It basically does sidecarring. It takes the EC2 instance, it takes the EBS volume, it takes a snapshot of it and sidecars it and checks what's on it and looks for vulnerabilities on the operating system, which is pretty slick. But it also has a pretty wide coverage of all the Amazon services. It knows all about them, it can inventory them, and it has controls for most of them. And it has support for pretty much every security standard that there is out there. It's also very good at looking at the instance, figuring out its ENI, and doing a complete trace of what it can see. So it's not just going to cut a ticket. It's not just going to report on a vulnerability because it sees it. It's going to say this is accessible by the internet, which means it can be exploited, and it makes it a higher priority. It supports serverless, and Amazon with Inspector has started to catch up with that. But I still think Wiz does better. Plus, it's multi-cloud, and we do have some footprints in other cloud providers, so it's a benefit for us. But it supports, it scans Lambda, it scans ECS, it's running containers, it checks ECR images, it does Lambdas, it does EC2, and like I said, it is multi-cloud as well. Splunk and XOR, I mentioned log aggregation. So our use of Splunk is mostly for CloudTrail analysis and guard duty analysis. So we send all of those events to Splunk, which then creates I just forgot the name of it. It creates a generalized view, sends that up to a tool called XOR, which has a lot of good, pretty solid hook-ins. And then that allows our security operations team to then escalate when they see certain things that they want to look at. Yeah, that's about all I got on that. It's a nice little intermediary tool that we use for some of our workloads. And then Jira and Brinka, we have something called the Morningstar scorecard. Every week on Mondays, management gets a message saying that you have a 1-star rating or a 5-star rating, depending on how well you're doing. And that goes across cost, it goes on operations, it goes on security, and it's checking Jira for that. So what we do is we're cutting, we've cut 2.2 million tickets in our time, and Brinka on Monday morning looks at the open tickets and assigns a rating based on all of that information. So, and then Jira is the interface for that, although some people think it's too noisy, but unfortunately, if you have a lot of vulnerability images, you got to deal with that. So, but of those 2.2, 2.1 have been closed. Part of our custom scanning is we've built an interface into Jira that's usable by anybody that wants to, and it does closed loop and it handles exceptions. So if something is spun up, it's vulnerable, we cut the ticket. If a team fixes it, if they forget to close it, we close it for them. If they try to close it, we're going to open a new ticket for them, and yeah, they can't get around it. We keep looking. And we do allow for exceptions. So for example, we don't support all of our golden images. So instead of killing, I think EKS, we don't support the base EKS one because it keeps changing. So we put an exception in for that. So it won't cut tickets and it will not terminate them. And I talked way too fast, as I always do. But if anyone has questions or wants to hear more about what we're just talking about, I'm happy to go about it. Yes, sir.
I'm not sure if you mentioned it, we spoke about Jira, but when you remediate something like an instance, how do you inform the users?
If we terminate one, sorry. Oh yeah. If for Jira, how do we have?
If you discovered an instance that doesn't use your AMI,
yes.
you want to kill it.
Yes.
Kill it, and then how do you?
For that we email, which is honestly a courtesy at this point. Most of our teams, the best behavior is when we turned it on. We'd see these emails come in, and it would take about 3 times. They'd spin it up once, it'd get terminated. They go, "Oh, that's weird." They'd spin it up a second time, it get terminated. They start scratching their head, and then they look and they go, "Oh, there's an email. Oh, I guess I'm not using the right image." And they look at the documentation, and it's usually someone who hasn't been in Amazon hasn't been using AWS for very long, and they learn the hard way.
So is the scorecard tied to that?
The time-based scans cut the tickets. The event-based ones usually do the killing. So, that doesn't. We could probably report on how many people have tried to not do it. It's something we could probably integrate pretty easily, but we don't do that today. Yes.
You said that you have 40,000 so roles. How do you manage that?
A lot. Yes. Yeah. Yeah. So we don't. I'm sorry. Oh, sorry. I keep forgetting to say that in the microphone. She's asking how we manage the 40,000 roles that are in our accounts. A lot of those are coming from the product teams themselves. That's one of the things we're trying to improve with Wiz, because Wiz we tried to do it custom where we'd go and look at every single role and say, oh, this is too permissive and this isn't. It's painful. Wiz has actually got it done pretty well. So they do report on IAM roles with excessive permissions, unused permissions. Again, they're very intelligent about the criticality. So if they see something that's publicly accessible and it has too many permissions, it raises the criticality so we can report on that appropriately.
Does it have AI or some similar capabilities?
AI capabilities. I'm sure under the hood they're doing something pretty intelligent, because otherwise we tried to look at it and it was actually pretty, it's not an easy problem to solve. So,
Yeah.
so. Yes, sir.
So your S3 Cloud Trail, you're all rolling up into a single bucket.
Yes.
And all by itself.
It is. It's in a security account, so it's it's isolated. Yeah, sorry. The question was the S3 bucket for CloudTrail. Is it in an isolated account? That's correct. It's owned by the InfoSec team, so they have access to it. Yes.
So you said you're finishing the transit gateway stuff. When are you gonna start looking at CloudWind?
We're just happy to be done with peering in the transit gateway project. He's asking about when are we moving to the next phase for CloudWind. I at this point I'd be happy for it just to stay where it is for now. Honestly, we're gonna probably revisit network firewall because it's expensive and we're managing it and we don't really want to. So if we can get something else that our network team can then take ownership of, that make us happy. Oh, I'm being recorded, aren't I? Oops. Yes.
So you said that you have golden images. I believe that you have a bakery account. Why don't you use another recipe that prevents people from running instance from image that does not originate from the bakery?
Good questions. There's a couple of reasons for that. Sorry, he's asking why we don't just use SCP to block people from launching instances if they're not our image. I'm gonna try to go through this in an orderly fashion. First of all, when we did this, we didn't have SCP, so that was a problem. But that's, we've had SCP for long enough that we probably could have done that. But what we found is, number one, exceptions are impossible. So there are use cases like EMR. I don't know if you've ever tried to figure out what the AMI ID for an EMR instance is. It's impossible because it's hidden. So it's not like you can find it. It only pops up when the EMR service goes and spins it up. And so we can't even deterministically find that. We'd probably also run out of space within the IAM limitations from a character limit, because there's, at this point, we're managing, oh God, I'm forgetting, maybe 8 or 9 instances, and we keep 6 months of it. And there's 7 or 8 regions, and there's overhead to that. And then my personal reason was the experience isn't very good because they don't know, all they get is it's blocked by a policy and they don't know why. And then they'd have to come back to us. Well, otherwise they have an email and they know why exactly they couldn't use it. So anyone else got any questions? Yes.
Matt, how are you managing access to kids?
Also through SSO. Through Okta, sorry. So yeah, Okta there we have, and actually I think we're using the same AD groups, the deterministic AD groups we have. So if someone has admin access in AWS into an account, they also get access to the same space in Wiz. Yes.
So you have like 13,000 S3 buckets.
Mm-hmm.
I mean, why do you have to create so many buckets and stuff?
Why do we have so many S3 buckets? We have so many S3 buckets because we have lots of developers. and you'll actually be surprised. We've tried to do some stuff with S3, and it's amazing how many Amazon services also just create S3 buckets. Like, for every CloudFormation template, it creates a bucket. For every asset, for every artifact within the CodeStar suite, it creates a bucket, and it's just, Amazon loves making S3 buckets also, but so do our developers. So
we use 30,000 buckets. I'm not really surprised.
Yeah, it's not that's the least one that's surprising. Honestly, the number of Lambdas we have was more surprising to me. So it makes me happy. I kind of like Lambdas. So yeah. I mean, half of them are probably called test and haven't been run. But we're hoping Wiz will actually help pare that down, because it seems more and more likely to delete something we're because we now have that visibility. We're going to start cutting tickets on that, and I guarantee when a team finds 1,000 tickets for Lambdas, they're going to be like, that one can go, that one can go, and that one can go. Yeah.
And one more question on the IAM user. You said there's no local IAM users, right? They're all federated.
Yeah.
So for service accounts alone, you have like IAM user, or for automation, IAC.
Yeah.
How do you manage this? Best practice?
We are using, like, I think I mentioned it, I should have sent this a little more, but for us, infrastructure as code, we're using Terraform. And so we have a space within our Terraform repository where we have a module that you can just basically stamp it out with the policy that you need and give a couple more pieces of information. And then once we've created it, the admin role is allowed to rotate keys. They're not allowed, but there's no passwords. None of them have passwords. There's no interactive login. It's just keys. We have something that looks for aged keys and cuts tickets after 3 months, and then they have to remediate that or else they get dinged on the scorecard.
So if we have the ISE and people are using ISE or the pipeline with the EC tools, right? And people don't have access to create, directly they can log in or create something.
Yep.
And why do you have that problem of having the AMI problem that we were talking about earlier? Why people are using the non-standard AMI?
Oh, not all of our teams are. We use everything as code. We're now trying to push a lot of our teams came into it. Like I said, I think our cloud journey started about 7 years ago. And at that time, a lot of people would just go into the GUI and go, ooh, next, and spin up their EC2 instance. Yeah, exactly. ClickUps. I love that word, actually. I'll be honest, I heard it the first time today and it makes me happy. So there are different teams that are further along in their maturity, and some of the teams are still doing ClickUps. And so, that's usually the 90% of the time we're terminating things that just someone's kicking the tires on. So yes.
Do you ever think you have like a security ticket eventually down the line, just do it as infrastructure as code and everything?
Oh, like cut a ticket. You're asking if we could, if we'll cut tickets for teams that aren't doing infrastructure as code?
Yeah.
That would be a good idea, actually. I like that idea. We'll make a note of it. Yes.
You said that you have everything in code. So in case you need to terminate an account, do you have an automated job for this as well?
Sorry. The question is if we have to terminate an account, do we have a pipeline for that? And honestly, we've killed like 2 accounts. Yeah. So we have like 3. We have our life cycle is kind of active, paused, which is we had when we first started, everyone wanted their own Amazon account. We're like, all right, great. We cranked them out, and then the bills started to come in, and a lot of teams said, oh, we can't afford that, and they said, all right, we're done with this account. And occasionally we would kill the account. And then a year later, they come back and go, we want our account again. And we're like, okay. So, our the email address for the root account is deterministic. And because it was held by this killed account, we had to go and find some hacky way. You could still technically log in even though the account was dead. And so it became a nightmare. So we basically, as long as the team existed, we'd pause the account instead. And then we can just and just rename it. So yeah. Exactly. So it's still there. It just sort of drifts and drifts. And then when we unpause it, it undrifts. Yeah, exactly. Like accounts are easy at this point. It's not, they just are. And their base stuff has very little cost, if anything. So, all right. Yeah. Oh yeah. Yes, Margaret.
And the banana is for scale?
The banana is not for, the banana is a fixed size. It doesn't really scale. So that's why there are no bananas in this discussion. So I'm glad I talked fast. Thanks for all the questions. Anything else? No? All right, great. Thanks so much for listening.
Okay. When I did the copy of consulting firm. Fully remote. I would fully remote. So pre-COVID. We were talking with it?
Yeah, we were talking about it. Nice. I mean, no, I'm just
remote for.
pre-COVID. But yeah.
I was gonna say from 98%.
Oh my goodness.
Yeah.
Yeah.
But all infrastructure underneath one place and it's wireless and wireless network. There's like 5 people going to. I gotta go and make sure the lights are still out occasionally. But it usually yells at me before they even yell at me. Getting more saying can't read.
Yeah, no, I work for.
Which one?
I've never done it. Email systems. No. They're part of the S&P 500. Yeah, 60,000.
They still compete. They're Kansas City based?
Their headquarters.
All right, I guess it's time to get going. So it's been fun being here as always at Community Day. There's so many passionate leaders, engineers, practitioners that enjoy building on AWS. We can all talk and share stories, have a good time. So my name is William Collins. I work for a network startup called Alkira. We build network software on the cloud. We use a lot of AWS. And today I want to talk about cloud networking, specifically Transit Gateway and sort of the road, the evolution of networking to Transit Gateway. I really like thinking in terms of like problems and solutions. So, you know, a gigantic company like AWS isn't just going to start inventing stuff that, oh, maybe someone will use it, maybe some will not. You know, there's usually some demand in the market, and the really good things are the things that, you know, customers are, you know, pestering them for, like, hey, like, this is how we have to do something today. You know, we need a better way to do this, you know, please, you know, come out with something. So my clicker's not working. Hold on. There we go.
Can I ask a question?
Fire away.
Do you have any opinion about Aviatrix? Number one. Number two, what's your thoughts about Lattice?
I'll start with Lattice because I've been, of course, prototyping it and doing a lot with it. I think it's great. So one question I get a ton of is Lattice going to replace Transit Gateway, or is Lattice going to replace this other thing? And no, it's not. It's going to work with these other things. So if you think of Transit Gateway is like stopping at like layer 3, and then you look at microservices on top of that and you think service mesh networking, you know, service to service interactions, you know, that's where Lattice lives. And, you know, Transit Gateway is just lower in the stack. And then, you know, Aviatrix, Alkira, there's Proximo, there's a lot of different products out there on the market. You know, this is a growing market, and, you know, all of them have their, you know, things they do really well. You know, rising tide raises all ships. And since they're a competitor of ours, that's, you know, we're all stopped there. So, so going into, networking and Empire, I'm going to look at networking and Empire, and there's a little story behind this. This is going to be really different than anything I've ever done before. So a few weeks ago, my 7-year-old, he's going to a Star Wars themed birthday party. So he is not old enough to really watch the Star Wars saga and understand it and, you know, go into all these things. So I'm giving him the bird's eye view. You know, these are the rebels. This is the Empire, you know, just kind of pretty basic explanation, and showing him pictures, small video snippets. We land on Darth Vader and he's just, it's tunnel vision. He's like, that's a mean man right there that's in that outfit. So we started talking about it. And then I thought, you know what if Darth Vader was an AWS customer? You know, they'd be a gigantic AWS customer, but they'd also be a hard one to work with, this Empire. They have gigantic scale, but it would be a tough customer. I would feel bad for that AWS account exec, because if you get something wrong, you know, they got the Death Star, they're going to blow your planet up. It's going to be bad. So I'm going to look at this story in this talk track through the lens of like Darth Vader. And we're going to look at hybrid connectivity. So every cloud story, there's the first problem that you have to solve. And the way that I think about networking is kind of broken down into 2 different areas. So you've got to get to the cloud. If you're maybe a large enterprise, and you have your own data centers. This is where your applications have lived for a really long time. That's where all your intellectual property is. Okay, how do we just get a connection to the cloud? Usually there's some sort of data center extension scenario in mind. We'll go into that a little bit. And then the next half is routing in the cloud. So at the end of the day, TCP/IP, BGP, like a lot of the things underneath all this stuff, it's kind of all the same. But in the cloud, networking works different. Some limitations you have that, of course, you don't have on premises. And there's some benefits that make your job a lot easier. So we'll look at networking in the cloud. And then we will conclude with going into Transit Gateway. What makes it special? And I've been doing the cloud stuff for a long time. Worked through some really hard designs, square peg, round hole stuff. And Transit Gateway is honestly my favorite product, released by a cloud provider up to this point. In between the sea of serverless this and serverless that. And it's just because it solved so many immediate problems that I was having and where I was in cloud at the time with a large company. It's just really timely. So again, going, with this Star Wars theme, let's set the stage. The empire is growing, kind of like a large, massive global enterprise. And they've grown so fast, they're trying to take over the whole galaxy. So this is gigantic scale. It's becoming very tedious to manage. And you have a lot of things that need to be connected. You've got star systems, you've got troop stations, data centers, you've got stuff everywhere. You have off-planet stuff. You're trading with, different planets. And then you have like the peasants of Tatooine that you have to manage and all these different things. So all these things have to be interconnected. And whenever there's a crack in this armor and you start having connectivity issues, everything goes uphill to the CEO, the emperor. So goes to Darth Vader first, Darth Vader gets mad, and then you go up to the empire or the emperor, and then things get bad from there. And then decentralized data, a lack of uniform security. This is a problem. One thing that is just historically relevant since cloud has been around. You have lots of accounts. Maybe you have some EC2 instance. It was created at a time when you didn't have, your security stuff in place. There's some metadata on there. Somebody is able to get in from the outside and they start moving laterally. And, next thing you know, they're in your data center. Bad news right there. So Darth Vader wants to lock all this down. He doesn't want any, rebellion. He doesn't want those Death Star plans, stolen. So first thing, hybrid connectivity. I've talked to a few folks at this event about the pains of using VPN tunnels. Site-to-site VPN it's challenging. So you look at this type of scenario and you basically have a full tunnel from your infrastructure directly to the VPC. Site-to-site VPN connection, you have an active and a standby tunnel. You have two public endpoints. If you've worked in networking and this was your first go at cloud, you already think you're an expert because you've been doing this forever. This is a simple VPN tunnel. So Darth Vader sees this and he didn't get to be the evil Sith Lord he is by, not thinking of things like redundancy, resiliency. So he's thought about this a lot. He doesn't like the idea of a single point of failure there. So what does he do? He adds a little more hardware. You have more VPN tunnels now. Each active tunnel is only shooting through 1.25 gigs for throughput, not a lot. And he really likes the idea of using all the stuff, like all the tunnels at the same time. He wants to use all the resources that he has. So again, he sees this design and while he's thinking about it, those wheels in his helmet are turning. Next thing he knows, growth starts happening like crazy. So if the empire, it's huge. They're going to have more than one AWS account. They're going to have a ton of AWS accounts. So that means they're going to have a ton of AWS VPCs. So as this starts to grow, complexity starts to grow. And I've never heard of any network engineer in my life, and I've been doing this forever, that was just like, I really like using VPN tunnels. Just bring on the VPN tunnels. Because not only is it tedious to deploy, but it's tedious to troubleshoot. You know, when something goes wrong, you know, the first area that gets blamed is usually the network. So yeah, rough job right there. So as this is expanding, more VPCs, more tunnels, you know, again, the wheels in the helmet start turning and Vader says, hey, we're gonna just shorten the span of these VPN tunnels. We're gonna go into a direct connect location. So we're gonna throw some hardware in there. So instead of having a full tunnel from the on-premises infrastructure directly to the VPC, we're gonna have maybe some circuits or some partner connection from our hardware, our facilities to this direct connect location. And then our VPCs, VPC A, B, and N there, they're going to be connected to some type of gateway, maybe a direct connect gateway. And this traffic, let's say I have VPC A needs to talk to VPC B. And this type of design and practice for most big enterprises, that traffic's actually going to come out of AWS. It's going to hit a router or a firewall and a colo, and then it's going to come back into AWS to the adjacent VPC. Vader doesn't like this. It's inefficient. So if the destination for this traffic is inside the cloud, why are we coming out of the cloud and then going back in? It just doesn't seem efficient, does it? So why is it that that happens? So there's a terminal, or there's something you have to consider in cloud. I'd say a limitation of sorts. So if you look at transitive routing, and this is basically to say that, you know, I can use VPC peering. So if I have VPC A and B, I can peer them directly, and, you know, traffic is passed, life is good. But say that I, you know, want to route to another VPC through that one. So I can't route VPC A to VPC N through VPC B. So what this means is if I'm using like VPC peering alone, and I'm not using anything else, there's no forwarding information base in a VPC. There's no routing protocols that say, hey, I'm going to give you the ability to route your traffic, to create route policies, and to basically control and limit, you know, the blast radius or, you know, failure domains here. So it's just kind of a one-to-one thing. Well, most times, more often than not, you don't want to say you have a security tool or something, some IaaS specific stuff for compliance. You don't want to have to put that in every single VPC. You want to have like a redundant and resilient set of VPCs across region where that stuff lives. And then you have, you know, stuff being enforced from there. So again, Vader doesn't like this. It's not efficient. So to keep traffic inside the cloud, I'd say the next iteration of this design. So first thing we had was, you know, traffic coming all the way out, going all the way back on premises to your data center, and then routing back up. And then the tunnel, it was a full tunnel from data center to VPC directly. The next iteration is usually a colo or a direct connect location that you're using as an intermediary kind of in between. And somewhere along I don't remember exactly when this design hit. I personally prototyped it pretty early on, but this is what is called the transit VPC. And if you think about lift and shift, almost sometimes has become like a bad word. It's a naughty word these days. Oh, you don't want to lift and shift things exactly as they are in your data center into cloud. It's going to be expensive. It's not efficient. It's not set up in such a way, because it was built in the early 2000s or something, that it's going to be efficient and scale properly in the cloud. So this transit VPC design is kind of like I'd say the equivalent of lifting and shifting your network directly inside the cloud. So in this design, our VPCs, you know, communication from like VPC A to B, it'll stay in the cloud because it's going to route through this transit VPC. And in this transit VPC, we're going to place 2 appliances. In this example, they're Cisco CSRs. So these Cisco CSRs are going to use BGP over IPsec to each VPC that we have. And there's going to be a lot of them. Again, it's usually active standby, 2 tunnels per VPC. We're only using, one of those tunnels at a time. And we're also going to do the same thing with on-premises. So we're going to use BGP over GRE, BGP over GRE usually for that communication. So tunnels on the left, tunnels on the right. So, look at this design and think, okay, I'm a big enterprise, or I'm the empire, and I have 100 accounts, or say just 20 accounts, multiple lines of business, and I have like 100 VPCs. Think about how this design looks. And beyond that, there's the same throughput limitation. So at the end of the day, at least when I was on premises, I didn't have, if I wanted 10 gig optics, or I wanted, when I'm routing something and I'm in control of the hardware, I can kind of size that and deploy it. In cloud, a lot of these appliance-based services did not have the ability to scale up, due to the nature of IPsec and a few other things. So this design, on the surface, we thought, hey, maybe this is good, but Vader didn't think it was good. The network has failed me for the last time.
There's no hardware acceleration there.
Mm-mm.
Something does not scale at all.
Nope.
You can't really take advantage of it.
Yeah, even from a cost perspective, I was in a conversation, this is years and years back, but they were approaching this from a cost saving measure, but I was like, well, you're paying Cisco for the licensing of these CSRs, you're paying AWS to run these CSRs, you're paying the traffic coming out of the spoke VPCs over the VPN, the egress traffic from the transit VPC, you're getting billed from a lot of different areas. And then you scale out. How is this a cost saving exercise? It's really not. So transit gateway. So transit gateway essentially is and it really operates like once you use it and once you deploy it in a real environment, it doesn't really act and behave like the traditional hub and spoke networks that we're used to in the past. So it's going to be usually a regionalized. So say I'm in US East and I have a lot of VPCs that I'm connecting, and then I have my sites, my, say data centers or, remote sites that I want to land there too. I can connect all these different things through something called an attachment. And using these attachments is pretty simple. And Vader liked this design so much. The ability of the transit VPC is insignificant next to the power of transit gateway. So we got a customer quote. So what makes transit gateway easy? So I went ahead for these next few slides. I personally like to automate as much as I can, usually with Terraform or CloudFormation. But you could do all these things through the UI as well. But the one thing I like for examples is with a snippet of Terraform code, I can show you okay, these are the only required values to create said resource. So that gives you an idea of the complexity. So to create a transit gateway by default, I'm essentially just putting in a description and a name, and I can create a transit gateway. That's how easy it is. Now this keeps all the defaults on, and we'll discuss that in a second, but what I'm going to get here is a transit gateway and a default route table. And from here, I want to connect these VPCs. So this happens through a VPC attachment. And again, it's really simple. So if you have in your mind what we were just looking at through this death by tunnels scenario, and then you look at this, much easier. So I'm just going to have, 3 lines there. So I've got the VPC ID that I'm connecting. I've got the subnet IDs for the traffic to route through, and the transit gateway ID that I created. So this will attach the VPC to the transit gateway. Awesome, that was easy. And one thing to add, so using the defaults. So when I create a transit gateway and I attach a VPC with the defaults, it's going to automatically enable route table propagation and in the design to actually use that default route table that the transit gateway is created. So say that we scale and we want more VPCs, then you'd want to probably disable that and use additional segmentation, which we'll get into in a second, because you don't want everything routing to everything, by default. So in terms of scale, you can provision 5+ transit gateways. It's a soft limit per account that you have, and have up to 5,000 attachments. So with as easy as it is to attach a VPC to the transit gateway, and it really fits well with, like most large companies have some sort of intake process. So something new comes along, new product, new service, you have a new VPC maybe, and this VPC has a life cycle. So that life cycle, there's going to be things that are built with the VPC and destroyed with the VPC eventually. And that VPC attachment fits right in there, really easy. So say for instance, and I'd say this is paramount for security, because one thing that I heard a lot of when I first started working in larger environments with cloud, like there was a lot of synergy and a lot of like enthusiasm that like all you need is identity and access management. Like IAM is the only security you need. It's the new perimeter. You don't have to worry about security anywhere else. You just use IAM and that's life. But what if your IAM is not, what if there's a hole there? What if there was something deployed and, something happens, somebody squeaks in and they're easy, they can just laterally move from VPC to VPC straight down to the data center. It'd be easy. It'd be a walk in the park. So this is where additional segmentation comes into play. So to do this is pretty simple. You create a resource, just a route table essentially, specific to the transit gateway, and you can easily just, I'd say it's a one-to-one mapping basically per attachment. So we're creating an attachment from VPC to transit gateway, and for each one of those, we may create like an additional route table, or we might want to consolidate some stuff like non-prod, maybe dev, QA, test, or like in some sort of non-prod segment, and then we have a production segment. Like say that you have healthcare, like PHI data, protected data is only going to be in prod. Everything else uses synthetic data. We are categorizing data at the highest possible level. That's how you want to segment, and it works. From here, you may be wondering, like, okay, we've got the VPC attachment, we've got the route tables, things are connected. Well, how do you control what routes to what? And again, this is pretty easy. 2 lines. You have route table propagation resource, or you can go into the console and do it as well. Just basically referencing your VPC attachment and the route table that you want to send routes through. And again, this is really simple. In terms of, I'd say, I did some sort of comparison a while back. Go ahead.
I was just going to ask a question about the number of routes you have in the route table is still not unlimited. Isn't it like 2,000 or 10,000 or something like that?
Yeah.
And that sounds like a lot, unless you work for an enterprise. And then that's not a lot at all.
Well, you don't summarize your routes and make them all clean and everything. Of course. No, I understand. So like I've actually, I myself, when Direct Connect first came out, I didn't know, this was back when like the documentation was not, I didn't, as a network engineer, I'm like, okay, we're just advertising this many routes. Well, like we had actually done some sort of change in a physical data center and had a whole bunch of host routes that happened to get advertised over the Direct Connect. well, the direct connect's down. What's going on? We had no idea. We looked in like 100 places besides thinking that it was a, that type of issue. So I totally understand that.
It's just a gotcha.
Yep, definitely. And that's with everything in cloud. Everything's, that's why a lot of times why you have more accounts, more VPCs, like there are hard limits and soft limits, and the route limit is a hard limit. So Vader's happy, uniform routing policies. There's no rebellion happening now. And in this, let's just say in this alternate universe, the empire continued to grow. The Death Star plans were never stolen, and everybody lived happily ever after. Woohoo! And that is it. That's all I got.
What's your thoughts about Cloudware?
I'll say this. So like Transit Gateway, when it was released, it immediately relieved active problems in like production environments I was working in. Like it immediately had a use case and it was like hit the ground running. Cloud WAN has not been so much, but I understand the problem that it's aiming to solve. And yeah, you just have trade-offs with everything. Like, do you want your WAN connectivity happening through a single cloud provider? You just have to think about those trade-offs.
Well, and Cloud WAN is not just about external, it's also an alternative to Transit Gateway.
Yeah, inter-regional stuff.
And it's actually modeled after something Azure did.
vWAN. Yeah. Yeah, it's interesting. One thing that I do know that I was trying to mimic or make work like Transit Gateway. So I do LinkedIn Learning instructor stuff too. And we were going to do a course on automating Cloud WAN versus automating Transit Gateway. And they just, yeah. Yeah. So segmentation and the way that you would approach segmentation is a little bit different as well. So that's a big thing to think about too. With Transit Gateway, it's pretty simple. The use case is hammered out and it's been around for 2018, I think it's been, 2018 for private sector. So it's been around for some time.
Hello everyone, my name is Michał Brygiden. I work as a cloud security architect for Zibia in Poland. But what I do after work is a bit more interesting because I wear a white hat and I'm a security researcher trying to get admin access on your AWS accounts. And today I will show you how I do it so you can protect your accounts from me. First scenario is very, very simple. It's just HTML. All you need to do is you need to take a look at the source code, check JavaScript, for example, or comments. It looks like that. It's still there. It's still live. Someone just left a comment for another team. And this is a part of configuration of credentials files for AWS CLI with access and secret keys here. And these keys were already for a user, IAM user with administrator access. So that easy, and voila, we have admin access here. What went wrong here? They decided to leave a note for next team. Hey, here's how we did that. If you just copy this, it will work the same for you. But the next team forgot to remove that. And in the first place, comments in HTML are not a good place to store your secrets. Let's move to another one, and this one is a bit more interesting. It all starts in GitHub. Last month, unfortunately, GitHub updated a search engine and a method of indexing code, so it's not that easy to find what I was looking for here, but still, let's start with public GitHub repositories. There are many, many repositories that you can all access on GitHub. And if you know what you're looking for, you can find interesting stuff there. For example, configuration files for different projects. And These files usually contain plain text credentials for you to just take and use. In my case, it was a bit more interesting because values of these variables were encrypted. So let's start first by showing you how it looks like usually in GitHub. You can find config files with some connection strings with login and password, or mail configuration, login password server, or any other connection type. Sometimes there are even AWS credentials that are still valid. AWS is doing a good job of looking for credentials on GitHub and then adding a policy, a quarantine policy on your account if they find something. But I found quite many credentials that were still working. But in my case, I found a credentials file, encrypted values. So I started to dig deeper, and in the same repository, there was a Java class with the whole logic behind the encryption and decryption of these values, including the secret key, the encryption key used for that. I asked them why. Oh, it's the only place where we use that. Okay, thank you. With that, I got access to Office 365 because the config file had Office 365 account credentials for SMTP, but hey, if it's SMTP, it may be a real user. So I logged in and I got access to a real user in Office 365 with access to all apps there. For example, Teams. So I was able to send a message to CTO saying hi, and he got a message from no reply at example.com. But there's nothing about AWS on Teams, so maybe find another place like SharePoint. Many teams configure their space in a way that is public in terms of the company, in the context of company. So if you have a valid account, you can access their SharePoint space and check their files. So I found a space owned by help desk team, and there was a PDF file with Jira configuration. The help desk team was asked to create a Jira instance, Jira server instance, and document every single step. And this is what they did. They documented every single step, including creation of the super admin account with login and password. And then next thing, I already found a login and password for Jira. So now let's find this Jira. And it was a public endpoint, jira.example.com. It was very easy finding. And with credentials, the super admin account, I was just able to log in there and check all projects. I was looking for projects with AWS in name, and there was quite many, but one was more interesting than others, and there was a ticket in that project. Hey, please create IAM user for us for Jenkins, and there was a comment. Oh, here are your keys. So thank you for that. It was admin access. What went wrong here? First of all, do not hard code your config values. There are other places like secrets managers like vaults. And if you push something by mistake to the repository, Git remembers. There's a history of everything that you push there. So it's not enough to just push a new version with some dummy value. You need to rotate the password that was pushed there and make sure that when I find it, it's not valid anymore. Then bad tools like why using public GitHub repository if the company owns enterprise version? It was help desk team. They didn't know what the developers were using, so they decided to use the first tool they found in Google. It was just create GitHub account and you'll have your repository. This is what they did. And yeah, they didn't know that the help desk team didn't know that if they put every single step in a file that is shared with the whole company, then the whole company can read the file and get a login and password to one of the critical systems. Next one, who uses PHP? Okay, we got one. Symfony Profiler. Symfony is framework, a PHP framework, and Profiler is developer toolbar helping you to debug the application. And it gives you access to server parameters, environment variables, history of all requests to that app, including post requests to login endpoint. And in older versions, you are also able to preview parameters YAML file or any other file from the application code. It looks like that. If you check environment variables, you can already see that there are some secrets, S3 key, S3 access key, secret key, but it's only S3 access. I need admin. S3 is fine if you need access to some data, but I need more. So I was looking for access to the application itself. And there's a search functionality for requests. If you just look for request, post request with code 302 and the endpoint is login, then you will find login request with plain text, login and password. Sometimes in the newer version, password is masked here in this window. So just scroll down and there's a raw request with plain text password. With that, I was just able to log into this app, in this internal app, and it was a dev version of the internal app, and the account gave me admin access to that internal app, but still it was a non-production development environment, dev.example.com. So what's the next step? Remove dev. And try it on example.com. Hey, guess what? It worked. So I had admin access to their internal app on the production environment. And the app had many internal apps available through the SSO, including CRM, but I don't need access to data, I need AWS. So there was webmail. And when I accessed that, I found a lot of AWS emails, invoices, trusted advisor emails, etc. So first thought, hey, maybe this is a root user account. Let's try to reset the password for that account on AWS. So I tried that, and I got a link to reset the password to that webmail, and I clicked it. I was able to reset the password and log in. No MFA on a root user account. And what's more interesting, it wasn't just a single account. It was the organization master payer account. So I just got root access to organization root account with a possibility to access admin role on all their accounts. Problems here, first of all, exposed development environment. If you don't earn money on the environment, just don't lose it. So hide the non-production environment behind a VPN or internal network only. And do not copy database from production to non-production, or if you don't do that, then also don't use the same password for non-prod and prod, because this is how I got in. And the email used as AWS root account user was also used for other services. There was a Datadog, there was a Cloud Health, and some more. So they were using a single account because they got access to it, and it was easy for them to use it. But it was also easy for me to access all other services from this single account. And no MFA. There are two things that I want you to remember from this presentation. One, use MFA everywhere. It makes my life harder. Next one, who uses Kubernetes? Okay, this one starts from publicly exposed Kubernetes control plane. I'm checking shutdown senses and binary edge search engines every week to look for new instances of Kubernetes exposed to internet. So someone decided to deploy Kubernetes in public subnet with public IP and no role-based access control on it. It means that if you know the IP, you can just connect to it and do whatever you want. And if you have access to the control plane, you can configure your kubectl and extract things like secrets. These secrets are base64 encoded, so easy to decode. Config maps, so the contents of configuration files that you use for your pods. And yeah, the list of all pods with configuration of them. it looks like that. It's the output from my tool that already grabs everything. It can find a list of pods. I can see if it's running or not, how old is it, namespace and name of the pod, then secrets, name of the secret and some credentials there. As you can see, sometimes even AWS access secret keys there. And then we have config maps and more passwords in here. So from secrets, I already extracted credentials for S3 access, but still it's not admin. I need admin. But it also contained login and passwords for Jenkins. I like Jenkins because Jenkins is usually admin in your infrastructure because you use Jenkins to deploy stuff on your cloud. So when I get in, I have access to your cloud. But I only have these credentials, but there was a pod running on the same Kubernetes called Jenkins something. So there are two ways to get in. Either find public endpoint for that Jenkins, jenkins.example.com, or try to forward port 8080 of that pod to your local machine, and using your browser and your local machine and port forwarding, you can get access to this Jenkins, and you already have login and password, so easy to just log in. When in Jenkins, you can check Jenkins credentials because many teams use Jenkins credentials as a secure way to store credentials. It's not secure; it's one-liner to extract everything from that. So there are some interesting. There were some interesting credentials there, like access to AWS, but only Lambda and SQS. There was also access to GitHub and other projects as well. But in the build log of one of the jobs, I found calls to AWS CLI. So I decided to just exec into the pod of this Jenkins and try to run AWS CLI commands. And yay, I'm in because it used a role and it was admin role. So this gave me access to their AWS account. What went wrong here? Yeah, first of all, public Kubernetes control plane. Why? In this case, it was just a mistake because they didn't know which one to use, so they decided to use the first one, and it was public, the public subnet. And I also asked them why they didn't use, they didn't add this one to the asset list for pen testing. Oh, it was only our development environment, and we do pen testing for production only. Okay, good for me. And then if there is any security feature enabled by default, preventing me to getting to your stuff, then please leave it enabled. Do not disable it. And there are many cases where I reported something to the company, and I told them that, hey, I got in. It's just it is disabled. Security module is disabled. Airbag is not in use. Oh yeah, but this is a random IP that only our team knows, and when we get there, everything is open because only we know that the endpoint. Nope. If you don't know how shotgun sensors or binary edge work, they scan the whole internet IP by IP, port by port, and they index responses, banner responses that they get. So I don't need to scan the whole internet. I don't need to scan your network. I already know where is the endpoint. So it's one connection and I'm in. Nothing in your logs because it's one connection only. The second thing to remember after MFA, principle of least privilege. So if you try to configure access for your colleagues or for services for other resources, make sure you give them only the kind of access that they really need to perform their task, to do their job, and nothing more. Common scenario, someone joins a development team and the senior developer says, oh, give him admin so he will have access to everywhere and he will not ask us every day for new access. That's wrong because when I get access to his account, I have access everywhere. Sometimes the problem is also in unprotected pipelines, CI/CD pipelines, because if you have a pipeline that is triggered by a change in code and I have access to your repository, I can push my code there and it will trigger your pipeline. It will build my resources in your cloud. If I have access to Jenkins directly, I can just bypass your whole pipeline that was defined in code. I can create my own job next to your pipeline, and I can deploy anything to your cloud. So yeah, there are many more scenarios. This slide was created like a year ago, and slides are still not ready, but let's do that. First of all, outdated software running on cloud servers, and this example is my favorite Atlassian product, Jira, in old version running on EC2. Old versions of Jira, Confluence, and probably even Bitbucket had a problem with one of the plugins. Our plugin had a problem with that it was working as open proxy. So you have open proxy on EC2. So let's just ask for metadata and get session credentials, and you're in. I don't know why, but they used IAM role on that EC2 with admin-like access. It was not full admin, but it was more than just power user because I had access to something in IAM. Next one, credentials logged in during the installation. I was asked to audit one of the customers' infrastructure, and they gave me a security auditor role, so read-only everywhere. And I found a Jenkins instance somewhere, and I already knew that it's public, and I was able to access it from my network, but it required login and password. So I was looking for a way in, found CloudWatch logs, log from my installation of Jenkins, last line, login and password to Jenkins. So yeah, that easy. Then misconfigured virtual hosts. This one is interesting. It shows you a list of all files and the directory structure on your server. And usually it's like you install Apache, and it gives you a default virtual host for HTTP and HTTPS. But then you wanted to serve your website, so you create another virtual host pointing to your direction. And if you access it by domain, then it points you to the right direction to your website. But if you access it by IP, like in this case, it's not configured, your vhost is not configured to grab the IP, and it goes to default one. And the default one is usually one or two story up. So hey, this is the list of your files, and this one is interesting, .env file, because usually this is where I find credentials. Next one, debug pages from different frameworks, and this one is Python Django. It's pretty nice, and it knows that it should hide credentials. If there is a variable with key or password, it should mask it. But then we have broker URL. It's either salary broker URL or just broker URL, and it consists of access and secret key. And I found many instances of this, and it was only one key that really gave me access only to SQS. All other were more than just SQS. Sometimes even wildcard access for EC2. And then a small teaser for my next presentation that I created this year, backdoors, because the hacking scenarios showed you how I get in, but now I need to stay there forever. So I can create IAM users with names similar to your users, so you don't know it's mine. I can modify trust policies on your roles. If you don't use infrastructure as code, but manually create roles, I can modify the trust policy and allow my other role from external accounts to assume your role. I can create my own identity provider with the name similar to your SSO, AWS SSO identity provider. And you will not know which one is valid, so I will still have my access there using external identity provider. Or you don't use AWS SSO at all, but you have an organization. I will enable one for you. I will create a AWS SSO for you with local identity store with my user with access to all your accounts. And you will not know because you are not using that service. Then we have servers. I can create a new server, new EC2 server next to your EC2 servers because you have a lot of machines and you will not know that there is one more with similar name. And with public access, I can just SSH into it and with a role attached to it, I can talk to your AWS account. Or if there is already instance running, I can just use SSM to log into your running EC2 and create a local user for me, because it was already misconfigured that there is SSH available from the internet. So hey, thank you for that. Then we have network access, and I can just share your transit gateway with my external account and attach myself to your transit gateway, or I can create a peering with one of your VPCs if I have access to your account. And then I will not have API level access, but I will have network access. And if you don't encrypt anything in your network, then I can talk to it and read it. And then we have services like the Identity Center. I already told you about Code Pipeline. This one is interesting because if you don't use Code Pipeline, Code Build, etc., I can create my GitHub repository with Terraform code. Then I can create Code Pipeline connection to this GitHub repository, and code build job that will be triggered by Code Pipeline whenever I update my Terraform repository. And you can cut me off from the account, but still I have access to the repository. I will push changes there. It will trigger the pipeline on your account, and it will rebuild all my backdoors. And the interesting one, Lambda function URL. You can create a public URL for your Lambdas, or I can create public function URL for my Lambda in your environment. And by just going to the URL, I can trigger the Lambda that will rebuild one of my backdoors or all of them. Also, a bit of hide and seek. If you find something and delete it, it will be logged in CloudTrail. So I can use EventBridge to look for events of where